All right. We're going to have another set of 4 sessions today. We'll soon pass the floor to Bertrand Lesseau from DG Connect, who will chair the first session. But before doing that, I'll also remind you that we have demonstration sessions. I hope everyone is ready also to go and visit those interesting new sets of demonstration today. They will happen again in the demonstration room and in the foyer for one of them. Otherwise, the chocolate contest is still on. So with that, Bertrand, the floor is yours. Thank you.
Good morning, everyone. Thanks, Michel, for the introduction. It's my pleasure to be here today with you. My name is Bertrand Lesseau. I'm with DG Connect, working on destinationers. Yes, I was saying that I'm very happy to be here in this morning session because this is a session where you see who are the brave ones. So congratulations, you were ready to be at the beginning of this new day of the workshop. Yesterday, I guess we've seen what is the state of play of Earth observation, and we were also able to draw perspectives for the future. And I guess this very session, which is actually mimicking the name of artificial intelligence and observation, but artificial intelligence on digital twins, will even push further the boundaries. Why? Because actually digital twins include observing the Earth. This is one of the key functionalities they should have, to be able to monitor what's happening at the surface of our planet. But they go beyond that. For instance, they should also give you the capacity to predict what will come, short term, but also on the longer term, within a changing climate, for instance. They will also give you the possibility to simulate different scenarios, and based on this insight, maybe to take decisions, maybe the best decision, or at least decisions you are accountable for. So I think that we're really pushing, designing a bit the future in this session. And for that, we invited 3 speakers to deliver keynotes. And to have a kind of quite diverse view of the Earth's components. Indeed, we will cover the atmosphere, the weather, but also the oceans and the cryosphere. We have also different perspectives, different point of views, people coming from institutional, international organizations, but also from research. So really, I think that we will be able together to define a bit what could be the future of Earth observation and beyond. So the setting of this session is quite simple. 3 keynotes, 15 minutes each. Then we will have questions that you can ask to the audience, to the speakers from the audience, but also on Slido. So especially for people who are online, I invite you to already open the Slido window. Thanks for the team to bringing the right slide. And also, if you are in the room, you can also upvote for questions that are on Slido. So you can maybe follow that also on your phone. And so we will use that to have the best question to our speakers. Now it's time to call in the first speaker of this day. So the first speaker is someone who really loves to tackle complex problems and who has actually a knack to solve them. So she was trained in mathematics, and she was looking for problems in the subtleties of geometry in the best institution over Europe. And now she dedicated herself to climate and to bringing AI to climate at the ECMWF. Please welcome on stage Sarah Hanner from ECMWF.
Yes, good morning. I think one of the key messages to take away from yesterday and probably today again is that AI is and has been revolutionizing the way we forecast the weather. And this revolution started in the atmosphere. And then partly and step by step has been taking over other components as well. We've seen yesterday already an overview of CLONET from Mercator Ocean. And also inside Destination Earth, we want to tackle the entire Earth system. That means not only the atmosphere, but also, for example, the ocean and the land component. My name is Sarah Hahner. I'm a machine learning scientist at ECMWF, and together with many other colleagues at ECMWF, at our member states, we want to show you some results today from the last 2 years that we've been working on that topic. Many of our work, again, builds on Anemoy. You've probably heard Anemoy yesterday again. I want to repeat it. It's a great software package. It's an open source software package we develop at ECMWF together with our member states. And it covers our entire pipeline that we need to build these weather forecasting models, from building the data set to building the model, training the model, and then also running inference, so producing the actual weather forecast. There are operational models running that are built in Anemoy already. Some of them are regional models at our member states, and then there are also 2 global weather forecasting models at ECMWF that we have running operationally. On one hand, we have to be patient. Well, on one hand, we have a deterministic forecast, and we call that model AFS single. We start with one initial condition, so the weather state, the state of the atmosphere today, and then we produce one forecast. At ECMWF, we focus on everything up to 15 days. And then we all know it's very difficult to predict the weather, so we not only do one forecast, but we also have an ensemble model to capture this distribution of possible initial conditions and also of possible states up to 15 days in the future. And we call that model AFS ensemble. These AI weather forecasts are ready in minutes rather than hours, so it's quite powerful. Once you have trained the model, which we all know takes quite a bit of compute, but once this model is trained, we can produce the weather forecast rather quickly. And Matt already mentioned yesterday that these weather forecasts are actually really good. So for many weather events, with these data-driven models, we can know about them up to a day earlier, including rain and then also including something like extreme events. So we want to build up on these powerful results in the atmosphere and develop AI Earth system models within Destination Earth. How do we do that? We use the power of EuroHPC, the compute power that we have available there. We use data from digital twin data to, of course, ERA5 and other data sets that we create just for the purpose of training these models. And then we train and build, train, and evaluate these AI models. So within Destination Earth, I've said this, we want to expand towards the entire Earth system. What does this include? This includes the ocean. Next slide, please. This includes sea ice and ocean, which we handle together in a marine model. We have the land component, we have the ocean waves, and hydrology. And these emulators we build while passing information from the atmosphere. This can be, for example, data from ERA5, or this can also be an AIFS or an IFS forecast. I want to give you an overview of our key results for these 5 different components that we put into 4 different models. Let's start with the land component. Next slide, please. For the land component, we've built an emulator. Next slide, please. Thanks. For the land component, we have built an emulator that takes information from ERA5. And then we want to see a physical, plausible reaction to this forcing that we provide from the atmosphere. And as you can see in this animation, this is the soil moisture for the summer of 2022, which has been one of the driest summer in Europe that we have lived, leading to crop failures, leading to problems in the energy supply. And you can nicely see how this land emulator, from the information that is provided by the atmosphere captured very nicely how the land dries out, because the land grows browner and browner, which is the color that we use there. So this is a quite impressive result, because this dry summer of 2022 was outside of our training period. It's drier than what we would normally see in the data years that we used for training these models. So this is a very nice result. And as you can see, I've linked a blog post where we go into more detail, where we also show some numbers if you really want to dig into the numbers. I do this for all the different component models if you want to go into a deep dive, or just approach one of us, approach me later in the day. And then on the next slide, we have a similar result for the ocean and sea ice model that we have built. It's again an emulator. We provide information from the atmosphere via ERA5. And you can see how the sea surface temperature in the different colors and the sea ice concentration in white reacts to this forcing that we provide from the atmosphere over an entire season. And in white, you see the sea ice concentration, and in red, barely visible, but I think you probably can see it, it's the observed sea ice edge. And you see how these two lines nicely fit to each other. So again, we can see a physical plausible reaction there to the forcing that we provide from the atmosphere. And now I want to go on the next slide to the ocean wave component. And here we've gone a step further and don't just provide information from ERA5 about the atmosphere, but we actually provide an AIFS forecast to our data-driven model. And so this, what you can see here in these two animations, I'll try to replay them, is two significant wave height forecasts. On the left, data-driven, and on the right, from our operational wave model, EC1. In the beginning of the animation, there's a storm in the North Pacific. And then the waves traveled over the entire Pacific Ocean for about 7 days and actually caused some damage along the Pacific coast of almost the entire Americas. And I myself worked on that model, and especially this animation was very impressive for myself to see. Because when you notice and when you realize, wow, this model that I'm building is actually helpful and can actually help to forecast some of these extreme events, it's very nice to see and a very nice motivation. So I'm very happy to be able to share these results. And then when we compare these two significant wave height forecasts, we actually see that the data-driven forecasts are again up to a day better than the physics-based model, just because we are able to provide also better information from the atmosphere, from the AIFS forecast, especially with the surface winds. And then last but not least, on the last slide, you can see a simulated and observed river discharge from our hydrology emulator. On the next slide, please. Thank you. In black, the observed river discharge, and in blue, the simulated river discharge. And you can see how these two lines nicely match. Our simulated outputs capture the seasonal cycle, capture the magnitude and the timing of high river discharge events. And here we've actually chosen a very different approach outside of Anemoy, because some who've seen this hydrological data know that it's not on a grid anymore. It looks very different. You have numbers for certain rivers that are measured. So here we've chosen a different approach, and this led to like the model that we call AIFL. Yeah, and we have now these models for all these different components. And in the next step, in the next years, in the next phase of Destination Earth, we want to bring them together and actually build this AI Earth system model. And this is something that nicely complements what is being done in the traditional physics-based models, where you also have separate models and then they communicate to each other. You can refer to it as coupling, and this is something that we plan to do now as well, and that these models communicate to each other, leading to physically consistent models that capture the entire Earth system. And we want to go a step further, and we are already going a step further together with our partner Predictia inside Destination Earth. On the next slide, please, where we are building a climate emulator. We use existing and climate digital twin data and train a model that then emulates our climate. And on the very right, you can see an output of that climate emulator. This is very recent results. You can see how this emulation captures the variability, shows physical consistent behavior, and is stable over long rollouts, which is not something that some of these medium range models are trained to do. So there was quite some nice work done. And I'm very sure you will hear a lot more about this. Yeah, and then I come to the end with my summary slide. On the next slide, please. Yeah, I hope I was able to make clear how these AI model enhance the capabilities in the weather forecasting domain. We see they enable faster, very cost-efficient simulations, and combined with improved predictions, we want to use these AI models to enhance interactivity. You have seen the demonstrator of Forecast in a Box yesterday already, and we would like to expand this and also input more models there to actually take advantage of this enhanced interactivity that we can provide with these quick and reliable AI models. With that, I thank you very much, and I'm happy to take a few questions. Question over there, on the very right. On the right, is there a question?
There's a question.
Yeah.
Yes. So Jenny first, and then Mark.
Yes, thanks for the very nice presentation. I was wondering if you have at ECMWF also activities where you would couple like a machine learning model to a physics-based model, like for example the IFS.
So we haven't done that yet, like coupling, for example, our AIFS to the physics-based ocean, because it also comes with quite a bit of technical difficulties. But I know at other research institutes they are doing that and experimenting with that.
You can maybe talk about that more. You can tell about.
Yeah.
Who is doing that?
Let's talk about that later.
Yeah, thanks. I was wondering how you prioritize what new component models to address and look at. I mean, you know, there are things, obviously you're covering a broad range of potential application areas, but I also see things missing in the context of developing an Earth system that, if I look at like requirements coming from policy and things, I would imagine to be actually perhaps more significant than some of the things you're addressing, things like biogeochemistry, ecology, carbon cycle. So how do we make sure that the prioritization of developing these component models is kind of in line with the current priorities that we're seeing?
Yeah.
Thanks.
Oh, it's a very interesting question, and I can try to give you my take on it, but you might need to talk to someone who has a better overview over that. But these 5 components that I've showed you, we try to treat them equally, because we have like one person working on each model. So this is something we treat very equally. And we do also look at a CAMS model. We have AFS composition in development. I'm not really sure whether that's part of Destination Earth, though. You might have to ask someone else there. Yeah. So we have like, I mean, I was trying to give you an overview here, but we really try to look at other parts of their system as well.
Yeah, hi, good morning. Peter Salomon, Joint Research Center, Copernicus Emergency Management Service. Thanks for the presentation. I was wondering, and it goes a little bit in line with the first question, do you have any plans of bringing these models, the physics-based model and the AI models together, building a hybrid system setup, or do you want to keep them separate?
I don't think we are keeping them separate right now, even with the approach that I showed you, because much of the knowledge and of course the data sets come from our physics-based models, right? Our data-driven models are only able to learn physical consistent reactions because they're in our data sets, because they're in our physics-based models that we use to build these big data sets. A hybrid approach that we are evaluating at ECMWF, though, is something that's called nudging, where we take coarse features from the AFS, bring into the spectral space, and then give that information to the IFS. So this is a hybrid approach that we are evaluating.
Excuse me, we will take, so for the sake of time, we will just take an online question. If you can ask a question at the coffee break to Sarah directly. Sorry for that. So,
thanks. So online we have a couple of questions. I just selected one of them. How much of AIFS is open source and available to other European researchers?
Well, we are very proud that most of our developments are open source. I mean, we build AFS in an open source software package. The initial conditions are now going into our open data policy at AIFS, so everyone is able to run it. We make the checkpoint for running inference of AIFS also available online on Hugging Face. You can use it very soon, as far as I understand, also in the digital twin. I know that people at ESA are doing great work to make that available. So we're very proud, actually, to say that we make this available and invite everyone to play around. And always happy to see someone else using it and come back with us, come back to us with good feedback, things that we need to work on.
okay, thank you very much, Sarah. Please give another warm applause to our speaker. And now I'm calling on stage Alain Arnaud. Alain was very nicely accepted to come to the workshop, to leave the Mediterranean Sea, to come in cloudy Brussels. Thanks very much.
The weather is nicer today here than in Barcelona.
Alain comes from Mercator.
It's the reason why I'm here, you know.
Okay, understand. He's a mastermind behind Editos, digital twin of the ocean. Alain, the floor is yours.
Thank you. So we try to test my digital skill with the system here. So thank you very much. I'm very happy to be here with you to be presenting this digital twin ocean, let's say, platform. You can change in presentation mode or not. If not, I continue like that. Okay. Thank you. Okay, so I'm going to talk indistinctly a bit about DTO, Digital Twin Ocean, and Edito. So it's a bit to wake you up in the morning to see if you're following me. So, and the purpose of this presentation is not just to talk about Edito and DTO, but also to explain why we consider today that AI is mandatory to be conducting this work of definition of this digital twin of ocean that is required by today to many purposes I will try to explain. So I try to go to the next slide. Yes, thanks a lot. So basically, first of all, it's something that maybe is could appear as less ambitious compared to what we have seen from destinationers before, when you try to have this big global model or models couple. Here what you are doing is much more to open a tool to the marine community in order to share the information, to share the knowledge, and really to have this possibility to act on the ocean. And I will really insist on this part because digital twin, this word of digital twin is a buzzword today. Everyone is talking about that, just normally for simple models. And a model is not a digital twin. A model is just a model. A model could be, as it's called in the let's say, vocabulary of this field, could be also shadow, when you have the possibility really to update this model in real time thanks to observation, acquisition. So here we have many data, for instance, coming from the Sentinel that are helping us for that in real time, or in situ data in the ocean coming from the MO nets that are helping us on that, but it's still a model. and it's still a real-time updating model. You start to have a twin when you are able to use this model to act on the physical world. And this is a complexity because you can imagine that a model inside a very nice HPC or big GPU is very far from this action. And what we are trying to do here with this digital twin approach is to, let's say, use the political and scientific community around the ocean, around the marine community, in order to have those actions. So when you will see the next slide, you say, okay, this is just publicity. We're telling that we are all the time with the president here, that she's very supportive of the digital twin ocean. So she asked for this digital twin in February 2022 in the Ocean Summit in Brest. We delivered to her a nice demonstration last year at the UN Ocean Conference in Nice. So we had half an hour with her presenting what was, let's say, the benefits of this digital ocean with the community, and also not just the European one in this case. We're having partners from Costa Rica here present. And we had also this digital twin ocean recalled last week at the European Marine Days when the president was announcing the new Ocean Eye program. I don't know if it's a program or activity, I don't know. But what is interesting here is that we are creating the link with this political world. And we know that, for instance, when we are deciding some applications on the digital twin ocean, this is linked to a policy, as you were mentioning. So, for instance, we have a lot of activities now on the BBNG, the area beyond national jurisdiction that are far from our coasts, that are difficult to be monitored. So it's very important to use those technologies to go, let's say, outside our control world in order to see what's happening in the BBNG. So we have a BBNG treaty that is supported now by some applications that we are defining on the DTO in order to support BBNG. So we have all the time this kind of balance between the technical push and, let's say, the political and societal needs here. So it's really what is at the essence of this DTO here. So we are lucky because we can support this DTO thanks to very nice observation. So like always, we can complain because we will complain we don't have enough observation, and especially for the in-situ part, it's becoming problematic. You know that we have some issues with our partners from the United States that are controlling half of the network of Argo, for instance. So we need to find solution on that. But besides that, once you have this information, what is important is to make it available. So this, we already started it in the Copernicus Marine Service, I think 3 years ago, with the arrangement of our data store around Arcosa formats that are very easy to access for the machine learning system. So this is already something that we have been performing for a long time inside the Copernicus Marine Service. So it just took advantage of that was available in order to feed the DTO. Next slide, please. Yeah. Okay, once you have the data, it was explained yesterday, it's very important to find let's say, the processing capabilities. And here it's really one of the weaknesses of Edito today. Despite the nice presentation we have seen yesterday about the AI factory, Euro HPC, it's not easy to get real access to that. It's not easy, so we are trying now with our colleagues from destinationers, especially in EUMETSAT, to get access to the GPUs they have on their bridges. But it's not really sufficient for the massive training we want to do for very big models that like GLONET that Quentin was presenting yesterday. So we are here having a weak point, and we expect that from this forum and the different also activities we may have together with DestinE and HPC people, we have a solution to solve that, because the architecture is ready, the problem is to get the resources. So we are really having a small problem here, in order to increase the resolution of our models and to have really a possibility to improve our modelization of the ocean here. What is true is that thanks to the, let's say, the new AI concept, once the model is trained, this is no more an issue, and we have the possibility with very limited resources to continue the processing. So If I go to next slide, please. So you have seen yesterday the presentation of GLONET. I will not come back to that. This is something that is now available on Edito. And what is interesting is that it's on demand. So for us, this is really changing because in this approach to have something that is useful, let's say, to take decisions, the possibility to have those on-demand processing and to link that to what-if scenarios is very important. Until now, it was very difficult when you wanted to say, okay, what is the impact if I change the position of this sensor, or if I do this kind of new policy? You needed days of processing in order to see the impact of that. Now you can have something that could be done on fly on the platform. So this is really helping. Next slide, please. Nice, okay. We are proud also to be part of this sustainable AI coalition that is, let's say, controlling a bit the aspect. So it tell me if you have limited resources, this is not so much an issue for you, and you will be right. But what is interesting is really to compare the consumption of a standard HPC compared to what we are doing with this GPU-based model. So we can also afford to have those on-demand processing because this is really less costful. We cannot be, let's say, running those processes during days and nights for a simulation if it was having a very big impact on the environment itself. We don't want, to kill our ocean just to trying to save it. So here, when you compare that, I try to have this marine comparison because when you talk about 1.5 megawatt compared to 1 watt, it's very difficult to imagine that. So it's like the weight of the blue whales compared to a sardine. So just you see the difference here. Next slide. Oops. Next slide, please. I don't know if I cannot. Thank you. So, as I was mentioning, what we are trying to do here is not to reinvent the wheel, just to be adapting those new technology, including, let's say, what the new AI system can bring us to what is already existing, so constructing mainly around the Copernicus Marine Service. So, for instance, we are now in our, let's say, service evolution, pushing to have a lot of applications integrated afterward directly on the Edito platform to be developed using AI. So what's happening in the last call. We have also in the Copernicus Marine Service a working group that is the DTO working group that is really helping to have our large number of partners in the Marine Service, more than 100 of them, that could, let's say, bring their skill and contribution in this co-construction of the DTO. So really trying to merge those activities because again, it's very important to keep our, let's say, high-tech activity close to the users and close to the marine community. If not, we are cutting ourselves from this possibility to act locally because also you know that in the marine world, most of the network of acquisition of in-situ data are managed by member states and other large institutes. So it's very important for us to preserve this close link between our member states, our local institutes that are already contributing to DTO and to Copernicus Marine Service. Next slide, please. So those are two examples of what can be done, for instance, with our partner from Norway, with NERSK. This is a nice model that, in a way, is similar to what you have seen before from ECMWF, that is done using a neural network and is able to predict the ice model. But this, again, is a bit different because it's used by the Coast Guard in Norway in order to have this possibility to really know where are the roads, where are the danger for them in order to do that. And it's just an adaptation of a service that is already existing based on the Copernicus Marine Service. So just with new technologies and this improvement in speed. So I think I have another slide of that, but I go fast. Next slide, please. Yes, thanks. So this is the example of what you see, let's say, between the new IceCast model and the observation done by satellites. This one is not yet a Sentinel satellite. But we'll soon have Simmer to help us on that. Next slide, please. We have also example of our, let's say, so just Italian colleagues, not you, that are helping us in having new models, you know, new AI-based model in order to do the modelization in Mediterranean Sea. So they are testing two kind of models, and again, the versatility of the platform is helping us to do that, to have the possibility to, let's say, to test new technology in order to see, comparing, and I go to next slide, please. With the ocean bench model that was described yesterday by Quentin, is very important when you have an open platform like that, to be able to control the quality of the product that you're hosting here, especially the on-demand one. So it's when you have this tool available on the platform like Ocean Bench, and people accepting to play the game with you to, let's say, to be able to benchmark your system here, you can compare that. So for the time being, this part on Med-Sea is not yet available in Ocean Bench, but soon we'll have that. So we have the possibility to compare the state-of-the-art model from Copernicus on the Med-Sea with the new AI model. So it's really something that is going on that with this, let's say, circle of evolution, validation, in order to preserve the quality of the Copernicus, let's say, standards, but in a very new versatile approach with the on-demand systems. Next slide, please. Okay, besides that, we have also on the platform the possibility to have some almost commercial application. In this case, it's a commercial service, but on which, for instance, a private company like Amphitreat are creating, let's say, services for chip routing. So the chip routing based on the ocean model is existing for quite a long time now. But what we are doing here is to have the possibility to improve, let's say, the standard models coming from Copernicus with high-level image, high-resolution, images coming from the Sentinel satellite. So you're able to place the HaDEA at the good position, and thanks to those high-resolution images. And this is really improving the quality of your chip routing. So I can see the improvement here, but you're really saving a lot of CO2 on across the Mediterranean Sea here. Next slide, please. This is another example, as you stated, so I'm going to go fast. That was done during a hackathon, where this one was really to see what is, let's say, the impact of those DTO approach on the tracking of fishes. So again, it's very important because this example is showing the complexity of the ocean modeling. We don't have just the surface and sea height and wave. We have several depths of a layer, let's say, to go to the deep ocean. We have a complex ecosystem here, coming, as you said, from geochemistry first, but also to the different kind of plankton up to the whales we mentioned before. So it's very important to have this global approach, and we know that nobody here is able to have this complete approach, knowing all the different scales and let's say science behind that. So this open approach of the digital twin ocean is really helping to bring the community to bring their contribution to that. Next slide, please. This small parenthesis on the DTO platform is not yet available, but we have that on the Copernicus Marine Service. I think it was mentioned also yesterday. When you are in front of such a complexity of information, so many applications and things like that, now we need to rely on agents to have the possibility to interact with your platform. So on the Copernicus Marine Service, you have the Blue Agent that is today able to answer your questions. So in my case, it was what is the temperature of the sea in Marseille today. And so the system is not just bringing you an answer. It's just telling you where is the information and opening for you the viewer in order to see really what is coming directly from the let's say the layer of, in this case, of Siemens. So this is very important. It's something that we're working a lot on the EDITO platform in order to merge this thing of chatbot plus viewer to give this interactive solution for that. And next slide, please. And I think it's the end. So thank you very much. I hope that you'll be interested in helping us to improve this DTO platform. And we had received again, so last week, this not request, but this recommendation to have it made operational for 2030. So just after the start of the new MFF. So we have a lot of work to do, and all contributions are welcome. Thank you very much.
Thank you very much, Alain. This is impressive. Do we have questions in the room? Maybe online? No. Yes, one question for the online participant.
So we have a question on ship routing. Does the ship routing application also include icy waters, such as the northern sea routes?
Sorry, I didn't. Which water?
The icy waters, the one with ice on the north.
I don't know, because I'm not the one doing the publicity for this company, so you can contact them, ask them what they do. I know that they are not the only ones, so I see some colleagues from other companies doing that here yesterday, so they are also welcome to come on DTO. Thank you.
Okay. Thank you very much, Alain.
Thanks a lot.
And our last speaker for today comes from KU Leuven, where he's a professor. He's a climatologist. He's also one of the leading experts in the strategic advisory boards of destination Earth, and I thank him a lot for that. He's also, and this is the role he endorses today, one of the co-principal investigator of the DT Ice Sheet digital twin. I'm pleased to welcome Steph Lermite on stage.
Okay, thank you. Let's see that I can stay in time. Yeah, good morning. So I'm Steph Lermite, and I'm here to talk about one of my passions, actually, and that's the icy worlds of our planet. And so we, with this consortium you see on screen, we have this very nice task to be one of these ESA DTC project, digital twin components, where we are building an EO-driven digital twin of the ice sheet. Now, ice sheets are a bit complex. Let's see if the pointer works. And I often sometimes compare them a bit to Las Vegas. They are far away. They're a bit mystical. Nobody really knows what happens there. But there is one very big thing, or one very big difference with Las Vegas, and that is that in Las Vegas, what happens in Las Vegas stays in Las Vegas, whereas if we look at ice sheets, what happens there definitely does not stay there. It has a huge impact on all of us. Next slide, please. And I guess, again, next slide, please. The timing does not seem to work very well. So what happens in Vegas stays in Vegas. Next slide, please. What happens in Greenland, Antarctica definitely does not stay there. If you look at the total sea level rise contributions, unfortunately, Greenland and Antarctica do not win the gold or silver medal. They're only on the third and the fourth place. So you could say, okay, why should we care? Now, next slide, please. However, if you look at their uncertainties, you see that Antarctica by far is the largest uncertainty. Next slide, please. And it's even fascinating. Here you see the sea level rise projections over time, over the different IPCC reports or the different major reports, and that the more we know, the less we know. Uncertainty has increasing over the life cycles of these different IPCC reports. And I think that's also something important to take into account when we talk about digital twins, is that it's not just a perfect representation, that whatever happens in the model is going to be reality. It's really that we sometimes lack process understanding, which make things complicated. Next slide, please. And the reason why these things are complicated is, for example, that both ice sheets behave very differently. Antarctica is a marine ice sheet. It's driven by ocean processes at the bottom. Greenland is more grounded on land. It's largely driven by processes on the surface. Next slide, please. So Greenland melts at the surface. Antarctica mostly melts at the bottom or at the edges, or it calves. And that's also what you see on the next slide, please, where you see that the mass loss is completely different. And in Greenland, it's a hilly place, and every year where they have low-lying ice, the surface melts because the atmosphere warms. If you look at the mass loss map of Antarctica, you see very different spots. On the interior, we are gaining mass because there's more humidity in the air, you get more snow. It's very cold, so even if you make it 10 degrees warmer, it's still very, very cold. But it really loses mass as these edges where the ocean is warm, and with warm I mean 0 degrees, warm enough to melt the ice. And that's actually driven by changes in ocean circulation. And these changes in ocean circulation are again driven by changes in our climate. But it's warm water from below. So next slide, please. So this brings us to a kind of a complex system where we have actually many stakeholders that want to know what happens with these ice sheets. Of course, there's policymakers. There's the general public that wants to know, is my city flooding? Should my dikes be higher? There is, for example, in Greenland industry, because meltwater brings hydropower, for example. And of course, there is these scientists that try to figure out how does this ice sheets work, because our uncertainty is constantly increasing. So we really need to get a bit of better understanding. Next slide, please. And there, I think that these digital twins enter the landscape. We have a user that has a certain problem. Next slide, please. Which has a certain question. What if? What if the climate warms? What if we emit that much? What if we change a landscape here or we put a dam there? And of course, we have models and we have observations. These observations can be fed into the models with data assimilation, and these observations can give us process understanding. And that's what we typically like to call it with these what-if scenarios. I think it was also mentioned in the previous talks before. And this interactivity, these are where the real digital twins are. Next slide, please. Now, one important remark I want to make here is that, as you probably might know, digital twins is sometimes for many people a bit of a vague concept, and it's also something that comes from industry. In industry, they started by making digital replicas of factories, and this is a bit how it looks like on this slide. You have a car in reality, and then you have a digital copy, and that digital copy is an exact replica. If you change a wheel, it will be the same. Now, if you look at how nature looks like, next slide, please, then the reality looks more like a car like this. It's much more complicated. There's many irregular things. It does not really represent, even if we have fascinating models. Many of the people here have already shown great work, fascinating models, but they're always a simplification of reality. They're often too simplistic or computationally heavy. So next slide, please. So are digital twins then the solution to this problem? I think it also was mentioned before. If we talk to people about digital twins, many say, yeah, but we already have that. A model, next slide, please, is for some people already a digital twin. If you're a city manager and you have a very advanced GIS system, they would also call that a digital twin of their city. So what is new here? Next slide, please. Next slide, please. So what is new, I think, is that we bring observations and models together, but that's something we've already probably been doing for a longer time. Next slide, please. Is that we put this AI layer on top of it. And this AI layer makes things possible that before were not possible. I think we've seen enormous speed-ups. We've seen models that learn behavior that are much faster, where we can do many more runs, where we can do interpretations that were in the past not possible. So I think it's somehow old wine in new bottles, but we have a new cork, we have a new etiquette, everything's kind of largely updated. Next slide, please. Because AI brings a lot of new opportunities, also from the ice sheet components. It allows us to learn from the imagery and make the models better. It allows us to do better updates. Of course, with the coming of emulators, we can now run models that in the past were not possible. Or we can bring the models to the users. You don't need an HPC anymore. As we saw yesterday's ECMWF example of AI in a box. These are things that also are true for many of our ice sheet components. And also on the other side, the learning capabilities bring us the capability of monitoring, forecasting, and scenario analysis. Next slide, please. So this is what we're now trying to build. It's an ESA digital twin component project. It's not huge, and we are a bit more than a year into the process, but we have a first prototype. This is, by the way, the first globe you see turning from pole to pole. It's not turning because we have this focus on both ice sheets. I will be at the demo booth later today to dive you into the prototype we have. So I'm not going to give a very detailed explanation here. But next slide, please. With this project, we have, of course, the classical stakeholders. We have the communities that are interested in these, the scientific institutes, but also, for example, on Greenland, the local communities, the climate modelers, the ice sheet and sea level rise communities. Next slide, please. And we are currently, as it's not a very huge project, focusing on 4 use cases only. One of them is looking at the mass balance of the ice sheets. Another one is looking at the ice shelves. That's the floating tongues around the ice sheets. They kind of behave as the slow car in traffic. They do not directly add to sea level, but they keep the traffic behind it moving slower. We have something on the surface climate, for example, to predict melt. And then, of course, we have, because that's where a lot of these applications matter, we have implications of if something happens there on an ice sheet, what does it mean for sea level rise on another place on the planet? Next slide, please. And so what we are doing is, at the moment, is building these blocks, which we call functional modules. These are just functionalities that we're now building for the ice sheet, but on the later stage could also be used in other ESA digital twins or even in any other type of digital twin. We're putting them together in different Lego blocks into, next slide please, this ice sheet component, which then later on, ideally, I think what we all see coming with this in this digital twin sphere is that we'll get a twin of twins, or like an ecosystem where you have multiple twins that you can couple together into one ecosystem consisting of all these small Lego blocks where we can put models or AI emulators together. Next slide, please. Under the hood, you can already flip a couple of times, yes. It consists of modules, which we at the moment are running on the DestinE platform. There's these data layers, and there's this access. So the thing I will show you in the booth today is a dashboard. Many of these things are pre-calculated. It's for easy access users to use. But you can also run the same functionality in Jupyter notebooks. So if you are a scientist and you want to do the hardcore working, you can launch your own notebook and get the same functionalities. It's supporting, next slide please, the upcoming technologies from ZAR and Stack for the data layers to fast API and poetry and so on. Next slide, please. And so it combines satellite data, some of the physical models that have been pre-calculated, some in situ data, and then a set of algorithms and AI. And as this today, we are in this workshop on AI, I'm going to dive a bit deeper on what the typical things we do. Next slide, please. I think the AI opportunities in the digital twin sphere are large. They go from monitoring to understanding to in these what-if scenarios. And then you can click 3 times on the slides. And there's many kind of buzzwords or techniques or ideas we can bring into these digital twin components. On the monitoring side, going from low resolution imagery to higher resolution imagery, to be better at classification, segmentation, to detect objects, to fill in gaps at periods where we don't have observation, to building foundation models, to get better at process understanding, to later build what-if scenarios, make these emulators or these fast surrogate models we've seen before, to even generative AI. If we have a model that's conditioned on, we can say, make me the ice sheet if the conditions is 2 degrees warmer. Within our own digital twin, next slide, please, we are focusing on some of them. So these are the ones you see highlighted here. Next slide, please. So for example, we are running super resolution models where, for example, melt detection on the ice sheets is typically done with passive microwave imagery. It's great. It has many overpasses, but it has a very coarse resolution. On the other hand, we have, for example, Sentinel-1, which has a lot of spatial resolution, but doesn't have an ice sheet-wide coverage all the time. We trained a model that could learn the high-resolution representations from the low-resolution presentations. Next slide, please. Of course, there's these many emulators. You can, again, click a couple of times, where we basically build these models where you replace the complexity of the physical models by a black box you put around it, which you then, in our case, next slide, please, we use it to predict sea level rise and or surface mass balance. Next slide. And so, for example, there is in our dashboard now a tool where you can play around with the temperature, for example, and see how much mass loss you'll get from the ice sheets. So this is really a what-if tool where the model, which is much more complicated, is being replaced by a fast emulator. Next slide, please. Similarly, we built these models where, for example, mass balance is typically controlled by a regional climate model, of which we have very few. So we learned emulators that could represent a regional climate model from a global climate model. And then next slide, please. And I think that's also my last slide. So Bernard will be happy. This is, again, kind of a summary. We have these 4 use cases. We're building these individual components. It's all still prototype level, but I think it somehow gives you a glimpse of what we all might be contributing to on the longer term. Thank you very much.
Thank you very much, Steph. And I guess I will go for sure to the demo booth to be sure to learn a bit more about that. Maybe we have questions in the audience. Yes, Vincent Henry. And general comment, if you can announce yourself on who you are before the question.
Yes, Vincent Ripek, ECMWF. So thank you for a very inspiring talk. Was really excellent. And the concept of building blocks or Lego elements, I think is truly interesting. My question is about how to make sure that the sum of these Lego blocks is something meaningful. I worked a long time ago in a project, a European project that was called Prison, which was about the same with old style models, was 2005 or something like this. And there were lots of groups in Europe having different types of models. The idea was to bring them together with a coupler and to do climate projections. It didn't work. It didn't work at all. The reason is that all the systems that are used for IPCC Cordex runs, they are tuned and adjusted to make sure that the bias of one component is. So I suppose that with AI-based system emulators, that would be the same. My question is how to use AI to make the glue between this system. Did you think of how to tune these elements in a way that can be meaningful and that the tricks that climate modelers have had in the past to offset these problems can be also adjusted in the AI world?
I think that's a very valid concern, which I actually completely agree with, and I am also a bit afraid that I don't have a reassuring answer. I think it's a bit the same what we see with the sea level rise projections, that the more we know, the uncertain the thing becomes. The more models you start coupling together, even if it's emulators, which if an emulator is at its best, it's equally bad or equally good as a model. It's never going. No, there's some of the weather forecast models tend to be a bit better, but most of the emulators, if they're optimal, they do so. And I think that there is an important role to play to educate people, because you bring different communities together, and it will be very accessible to start playing with a tool on a system where you have almost no knowledge about. And I think that's a big challenge for us as a community, is that the tools should not be too accessible, that people start. They should be accessible, but if they become too accessible, then you have a risk of becoming bullshit generators. Yeah. Yeah.
Okay, another questions? In any case, I guess yes, Jenny?
Hi, I'm Jenny Kontkanen from CSC. So I was wondering, if I understood right, you are currently focusing on, or you are not focusing on like climate timescales. So I was wondering do you have some plans also for that? And if yes, what kind of plans?
Yeah, so it's an ESA-driven project. So the focus at this moment is on the past, or the recent past, because we're driven by observations and not by models. But of course, the ISMIP, the ice sheet model, so running ice sheet models becomes climate scales. And so that I think definitely is, so the what-if scenarios, definitely for ice sheets, they play on a very long time scale. It's hundreds and even 300, 400, 500 years where sea level starts to matter. So I think bringing in the ice sheet models and bringing in then the actual forcing to drive the ice sheet models is going to be an absolute necessity if we want to make this useful. Yeah.
Thank you. And we will have questions also from the online attendance. So Daniel.
You touched a bit on this question, but it's quite popular online, so I need to read it. How will the results of this ESA project be integrated into DestinE?
So the digital twin components are currently focused on different topics, and our goal is now to really make these functional modules, and then bringing them together is part of the next call. And I think it's part of the discussion, how all these different components should flock together. Now I think most of them are based on similar upcoming technologies, or on similar. So I think it's mostly a tech task, which I think is probably more easier than the knowledge gaining task. Yeah.
And we have one more question, which is also gaining popularity. So it started from a quote that you made during the presentation, saying that the more we know, the less we know. The question is, could this be misused by climate change deniers?
Of course.
And if yes, how do you see the communication process to actually communicate climate change more clearly to the public?
I think, of course, and I think that's where if you make these tools available, you will always have a cherry picker that will find a way where if you couple model A with couple B with parameter C, that the sea level globally will diminish. That's where cherry picking, that's how cherry picking works. I think the communication should be that we know a lot, and that we are very much, I always refer to the IPCC report as the Holy Bible, because it's not one study, it's the combination of all the studies. And I think there we clearly see that we understand the system, but that I think perhaps I would like to redo my quote. The more we know, the larger the uncertainties become, but the average signal stays the same. We just get much larger potential outliers. And that's also what you see in this graph, is that we start to have very large uncertainties, so low probability but high risk scenarios of losing a lot of mask. And I think that needs to be clearly communicated. Yep.
Okay, thank you.
Thank you.
For the questions. Thanks to all the presenters for the high-level talks, also because I guess you expanded a lot the breadth of view we could have on the digital twins. I guess it's time for a well-deserved coffee break. Yeah, I think so. And we can continue the discussions on digital twins and beyond there. Thank you, everyone.
Okay, let's start, and then maybe little by little more people will join us. Hello, good morning, everyone. We start session 6, AI in Action. My name is Vasilis Kalogiru. I work in the EU Agency for the Space Program, EUSPA, and in this session we have the title AI in Action, which was a bit challenging, proposed by my colleagues, Mitch there. So we were thinking to keep it, but what are we going to do? I don't know how much actionable it is. So don't expect jugglers and stuff like that. We try to, or play, or we'll do some theater, whatever. But we have also some actionable component that will show at the end, possibly at the end of the session. So yeah, that's the little secret that we have. There will be no slides, so no need to see slides. We will have a panel discussion. So we saw yesterday, but also today, more of sessions on the, let's say, institutional setup, applications and services. These sessions looks into the industry. We go to discuss challenges faced by the companies that commercialize AI solutions that are based on Earth observation, but also the opportunities that are created by the projects we have, Horizon Europe project primarily, and other entrepreneurship activities leading to wider Earth observation and Copernicus adoption. I have an excellent setup with panelists that I'm going to call one by one to join me, and I will ask you also to welcome them. I'd like to thank them for doing the effort to join us here in Brussels. So, all set up, and I would like to call first Betty Haralambopoulou. Betty is the President and CEO of Geosystems Hellas. Please give an applause to Betty. Betty is a geologist with a specialization on remote sensing, photogrammetry, GIS applications. She's very active. She's many things I will just mention. She's an elected director in the European Association of Remote Sensing Companies, AIR's representative as well, and also in GEO post-2025 working groups. She's elected in the board of the Hellenic Association of Space Industry, where she also acts as head of the Earth Observation Working Group, and many other things I won't mention all, Betty. Next goes, I would like to call Konrad Bielski. Konrad, you're here, thank you. Konrad is the co-founder and Chief Technology Officer of Riskognition, recognized expert in space data integration and geospatial high-performance computing, with over 2 decades experience in operationalizing advanced Earth observation solutions. He leads the development of scalable data infrastructures, AI-driven analytics, and Copernicus-based services supporting disaster resilience, environmental monitoring, and climate intelligence, including also some services and capabilities for Copernicus Emergency Management Service. So thank you very much. Konrad, take a seat. I'll give you a microphone in a moment. Then I would like to call Fran Martin. Fran is a product and project manager in Earth Pulse with a strong background in Earth observation and geospatial technologies. Fran leads the end-to-end transformation of geospatial datasets into scalable, market-ready products. We'll talk about them in a moment, combining strategic product definition with rigorous project management. Thank you for joining us, Fran. Then I have Daniela Ristic-Duran. Hello, Daniela. Daniela is a senior R&D project manager at OHB Digital Services in the EU Downstream Services Group, focusing on the development of EU-based services for various application fields. Daniela, we go romantic now. Please have a seat.
Yes.
I don't know, online they can... I hope all okay. We can continue even this way. Then I would like the last one to call Mahi Simeonidou. Mahi, join us on stage. Oh, thank you for that. Thanks a lot. Mahi is an agronomist and entrepreneur specializing in sustainable agricultural development and digital farming. She's the co-founder of AgroApps, a company that develops innovative digital solutions for the agri-food sector. So, thank you very much for joining. Maybe some microphones. Yes, we can disseminate. So I will be brief, providing some thoughts of discussion, a little introduction, let's say, before jumping into the panel and start discussing, maybe food for thought and to put some meat on the table on our discussion. So on the 19-23rd of January in EUSPA, we have organized the EUSPA AI Week. We had invited some of our Horizon Europe projects, 15 Horizon Europe projects, during the week to present to us and showcase the AI-based solutions that they built. We touched upon various applied solutions of AI. We talked about how AI can be used to particularly develop foundation models. We talk about embeddings, applications on mobility. It wasn't only about Earth observation, it was also some application of GNSS. We talk about AI for environmental applications, forestry, disaster management, so industries as well, how regions can even profit for EU-based AI solutions. So we touched upon all the various thematics. I would like to give you, before starting, a little bit some highlights. I don't know how many of you were online or participated in the EUSPA AI Week. So some highlights for the discussion here. We talked a lot about AI training datasets, and this is usually is brought up in discussions and panels, how the training datasets particularly can be a big overhead for SMEs. Through the project, of course, through Horizon also projects, companies specialize and can standardize and benchmark training datasets on selected use cases, and that was an industry discussion. Many mentioned the lack of training datasets in niche use cases, not the generic use cases that are out there, and you have maybe well aware on training datasets to be found online and openly available, but there are some niche use cases that simply training datasets are not available, and companies are most of the time specialized and use these Horizon Europe projects to build them and maybe later even monetize on these solutions. It was mentioned a lot, AI will not solve everything. Many of the use cases require, of course, physical models. We saw also the examples from other colleagues on the usage of the physical models and the interplay between physical models and AI models. So in this kind of hybrid solution for certain use cases. We talked about explainability, and it was also in this event, in the first day, discussed in one of the sessions. Explainability is a very important element for gaining customer trust. And also there were some inputs that maybe also Commission colleagues would be interested to hear about the long-term commitment from the part of the Union, which is very, very much critical to SMEs when they build business models and the availability of the data. These were aspects were discussed. So we heard about the urban resilience, agri-food sector, climate, disaster resilience, forestry, mapping, photogrammetry. We have a good range of applications, I believe, in the panel, and I would like to thank you because we spread a bit the range. Now, I'll have to take one microphone and maybe sit with you. Okay, thank you. So, first of all, I would like to ask you a bit to describe, your work that you do in your companies, and particularly about how AI impacts and supports maybe your Earth observation value proposition. I'd like to start with you, Mahi. I mean, I know all of you personally, and this is good because it makes for a more fluid panel. I know what you have done, let's say, for us and various projects we will be discussing in more detail, but maybe as a first introduction, also for the people maybe that you don't know you, a little bit more on the AgRabs and how AI plays out with what you are developing in AgRabs, Mahi.
Thank you, Vasily, and thank you so much for having us here today and giving us the opportunity to discuss on this topic. I think that nowadays we talk more about AI than anything else. Not as a buzzword, but as a new reality. To us, it's not that new, to be honest. We started AgRabs 10 years ago. The focus was to build digital solutions for the agri-food sector, the agricultural sector in general, and try to find solutions that would help them, farmers, the agri-food industry, the cooperatives, some organizations as well, to find ways to monitor and to make better informed decisions on their everyday activities. And we started that because 10 years ago, along with the first time that we had the opportunity to use observation data for agriculture, the resolution was very good. We had for the first time those data in our hands, and we started trying to build those services. What was not easy to do, and that was the luxury that we had with EU projects, was the fact that when you talk about agriculture, you talk about a very complex system. And you need to have pilots, and you need to have the users involved, and you need to have all this data needed for you to build the models. And the truth is that when we started that, we had so many fails that you cannot even imagine. And this is where the luxury comes, because in research you have many fails. For us, machine learning at that time, using the data that we got from Sentinels, was something that was our everyday life. It wasn't a buzzword, it's something that we have to do. And along with agronomic models, we were trying to build solutions for our users and at the end, our customers. Now, 10 years later, we are still here. We are having a very good and solid customer base, and we have been able to, I think, to succeed in bringing those solutions to the market and keeping those solutions to the market, not only bring them as a hype or something like, that works for a while, but something that's stable, and year by year we see that growing. We will discuss about more later.
Yes, I could use, but thank you, Vasilis, first for introduction and for inviting me to present today OHB Digital Services. OHB Digital Services belongs to OHB SE, which is one of the leading European space companies. And maybe some of you knows for OHB as a producer of satellites, but recently OHB formed also this digital business unit that we belongs to, with which we are now using satellite data also to develop different services and digital solutions using the space and advanced digital technologies for different application areas. So in this structure, OHB Digital Services is an IT company developing different services, operating internationally and nationally in Germany, and also supporting both institutional as well as commercial customers. One of our main or core activities is developing of Earth observation based services or Earth observation based practical solutions for different operational applications. In this, we are combining satellite data with cloud technologies and artificial intelligence. So to support operational activities in different sectors such as transport, critical infrastructures, maritime, and urban resilience mainly. But one of our core activities is also developing the platform. We call that preprocessor. So to develop these services as Copernicus first, because the goal is also to develop affordable services and then to use also as a first open access data. For that, artificial intelligence is very much needed to improve some functionality, some characteristics of data, and also artificial intelligence we use, as we all use, to analyze the large volume of data, not only Earth observation, but also other data sources. And today I will present at the end some of our results.
We'll have the little secret at the end indeed. Fran, about Earth Pulse?
Hi, thank you, Vasilis, for the invitation. Very nice to be here. Thanks for the introduction. So I'm Fran Martin. I'm the geospatial product and project lead at Earth Pulse. Earth Pulse is a startup based in Barcelona, founded almost 6 years ago. And what we do, in a nutshell, is to transform satellite Earth observation data and geospatial data into business decisions, okay? So we are now focusing on different use cases and different markets, especially for the monitoring of critical infrastructure in terms of climate resilience, monitoring landslide risk, wildfire, flood risk, and also into environmental compliance, supply chain. So you may think, yeah, there are a lot of different use cases, a lot of different applications. That's why we have SPY, which is our code platform that allow us to develop and scale and implement these operational services. Obviously, in all of this ecosystem, we use AI, but I'd like to say that AI is not our goal. I mean, it's part of our core business, but it's not a goal, but an enabler, technology. I mean, we don't use AI for everything. We don't use AI for simple algorithms, but AI is amazing when we need to complex and to modelize complex things like risks, when we need to process large volumes of data. This is in this point where we use AI, and I mean, we are very good at that. So yeah, very nice to be here, and later I will talk about the different projects we've been involved.
Indeed, thank you very much, Fran. Konrad, what is going on in Riskognition? Tell us a bit.
Thanks, Vasilis. At Riskognition, we're also an AI-driven company who's taking advantage of the Earth observation data to deliver services and real-world sort of workflows for the customer. So, I mean, again, as was just said by Fran, the fact that AI isn't the end goal, it's really a tool that we can take advantage of. In our case, we're focusing mainly on infrastructure companies and insurances, and therefore, from a management perspective, they've got assets that are global. So this is so Earth observation from that perspective is really important. With the AI, it becomes much more easy to develop the workflows and scale down as well to the asset level that is needed by these customers. From an ESG perspective, also, that's the types of services we can do more broadly, not just in the insurance and infrastructure sectors. But essentially, we use AI as a tool. We're not the AI developers. We take advantage of what's available.
Thank you very much, Konrad. Betty, I left you last because today you have double hats here. Okay, so the question that I'm pointing to you is, mostly as a geosystem LAS first, and then I will double up with a second question on the association and the work that you do. So tell us first about geosystem LAS, what you do and how AI impacts your...
First of all, I would like to thank for this invitation. I am Betty Haralabopoulou, that I am the CEO at Geosystems LAS, as it was mentioned. It's an SME based in Athens since 2009. Mainly the company is working on Earth observation, and we use AI as an enabler. Means that as it's a major need of using big data sets, data fusion, etc., AI is an enabler in order to receive results in a good time frame in order to serve our customers. But we don't use AI as the unique tool. We think as company that the human mind is much more valuable than any algorithm running in any system. We mainly focus on the built environment, means cities and critical infrastructure, ports, airports, highways, etc. And there is also the interference of humans, because the built environment is used by civilians. So in order to use AI for our customers, we involve a lot of effort on the technical part, but also a lot of effort on models, calibrated models, in order to be aligned with the need. Because we are speaking for citizens and citizens' use of the built environment, and of course critical infrastructures, etc., etc. On the other side, because we are, our customer list is mainly based in Greece and Cyprus, that are countries that first we have a lot of maritime sector working in the field, assuming that Greece has 300 islands and ocean around. We are also focusing on maritime sector, and by working on the maritime sector the last 5 years, we are a lot involved in the border security. In the beginning, in 2009, when we started, the border security was mainly on land, but in the latest years is mainly on maritime.
Yes, but I will stay a bit with you now, changing your hat maybe as a member of the board of directors of ERSC. What do you gather better of the work that you do in ERSC with the companies in terms of the challenges on applying AI? What do you gather from the companies? What are the challenges they face? And if you have some maybe even quantitative data to share with us.
Yeah, that's why I have the figures in the paper.
Go with the figures. We won't show any slides. Go with
no slides, just the figures orally. Just for a few words about the European Association of Remote Sensing Companies, for the one that doesn't know, is a membership-based non-profit organization based in Brussels that has a network of more than 130 companies working in the field of Earth observation in Europe that are based in between the 25 member states countries. ERSC is covering the whole value chain of Earth observation, starting from the ground stations of commercial operators, of course, going to end-user services tailor-made to the customer need, and of course consultancy. And one major thing that we make as ERSC is that every year we make a study, an industry survey, in which we calculate figures. And by this calculation, we put also questions to our members, and not only to our members, but also to other companies that they would like to contribute, in order to have concrete idea how the market of Earth observation is growing in Europe, in which sectors, and who gets the benefit. So by the last survey of 2025, based on figures of 2024, I can say that in Europe there are 811 companies which are working, among other things, or dedicated to Earth observation. And for those companies, there is a figure of more than 16,000 employees, giving a revenue 2.66 billion euros, which is a good figure to say. And with this calculation, we can say that the last 5 years, we have a growth of 9.16 as a rate. There are several assumptions for this figure. One assumption is that, first of all, algorithm and AI in action, as it is the panel name, gave possibilities to very small companies and spin-offs to work in different fields the last 5 years, because there is, logically, the last 5 years, there is a boom on the technologies of artificial intelligence. On the other hand, if we see the map of the services around Europe, number 1 is defense and security. Number 2 is agriculture. And number 3 and 4, we go to the built environment, means smart cities, infrastructure, etc., etc. Another thing that we have calculated in the studies, and I have to mention, is that in the last year, we found out that small companies market lost 50 million euro. And this is for the first time. And those very, very small companies, some of those companies went down on bankruptcy or closed down with this loss. And this has to do, in our point of view, with the great growth of the two sectors, the defense and security, versus other sectors, for example, citizen and society, which is a smooth development versus the things that have to do with defense. So I think this is the current landscape, and this landscape, we are based in Europe. We are in between two wars. We have to monitor what will be the next day, the next week, etc., in order to get some more concrete outputs as a European Association of Remote Sensing Companies. Saying that, I have to say that as ERSC, we have one pillar that we represent the sector in working groups with liaison with the European community, with the Commission, and also ESA in several sectors. Also, we have a representation in the GEO. I was appointed, for example, for 5 years in the GEO post-25, but actively working with all the members of ERSC in order to deliver what was needed to go through. Also, with those working groups, we monitor everything that has value for Earth observation, and of course, the Sentinel's benefits for the Europeans. And we have some commercial tools like the EOMOL and the EO magazine that those promote the whole sector of Earth observation. So by saying that, I think I have mentioned the use of AI from our members. The tricky point for the very small companies that they were just launched out the last period because of the AI as a tool. And of course, how the market is going, speaking on the European level.
Thank you. Thank you very much for this overview. First on the activities of EARSC and the statistics that you mentioned, which are, I would say, aligned to what we also gather as EUSPA from our market report. Our next one will come, so we get what you produce also as an input actually on our market intelligence activities. We see some increase, let's say, on revenues in general terms, but also the fragility, which goes to what you just mentioned. Now, in terms of the challenges, I will stay, and I don't know who wants to take the floor. Apart from what was mentioned, if you have something, the rest of the panel to comment, maybe Conrad, challenges for risk cognition specifically. Yeah.
Sure, because we're a small company, and we certainly see that flip to the defense side, but we're not doing that at the moment. But one of the main challenges still for small companies who are not developing the AI is how to integrate it. So on the one hand, we still have to do a lot of pre-processing. We still need to analyze the imagery. So that's a big job. The other challenge linked to that is then to transform that data, so transform what the AI is doing into the workflows of the customer. So making sure we understand what their needs are, how we can transform that EO data, and then bring it to the customer. That said, the customer still needs to be, validated. They need to trust that data. So we have to be quite open that it's, we're not just using AI. We still do have a lot of expertise in EO analysis. So that trust and verification is definitely a challenge when it comes to EO through AI down to the customer as well. Yeah.
And that will require working, I would say, hand in hand with your future customer. And we will come back to that, how you do that maybe in the framework of the project.
Yeah.
Anyone else would like to comment on that? I don't know, Fran.
Yeah, I mean, I fully agree with Conrad. I mean, from our side, with our experience, on the one hand, we have data scarcity, data quality, and especially data access. I mean, all of us know that we have a lot of information available, but accessing this data is quite difficult. So we have the CDS, we have the DestinE Earth Data Hub, and don't get me wrong, it's a lot of information, it's amazing, but it's really difficult to access any data set, every data set you need in the correct format, harmonization. This is very difficult for us still. This is on the one hand. On the other hand, it's changing the mindset from science and research to operations, so what is called machine learning operations, MLOps, because in infrastructure, it's another challenge. I mean, when you need to scale your operations and going from regional level to worldwide, this is where challenge arises, and you need a good infrastructure, and you need a very, very nice pipeline, ecosystem for that. And the last point, last but not least, I think again is trustability. So as he said, users don't want anymore like black boxes. They want to understand AI. They want to understand why the model is giving a result. So they want to understand the variables. They are not going to believe blindly in the results, but they need us to help them understand why they are taking those decisions, because at the end, they can be critical decisions that they can't trust anything. So I think these three are the main challenges we are facing right now.
Daniela, is there anything left more to comment?
I think in situ measurements are not mentioned.
Okay.
So yes, as all my colleagues said here, we are the main challenge, one of main challenges are data. So we are all missing large volume of high quality data. And I would like particularly to focus on need for high quality and large volume of reference data, in particularly in situ measurements, needed for training of AI models, but validation. So we are also, as a company, using AI and integrating into our systems whenever it's needed and bring added value. And for training, it's necessary, but to validate, it's needed to convince customer that the results of the system based on AI is valuable. And of course, the type of data needed depends on particular application. We as a company try to come up with some innovative products and innovative Earth observation-based solutions. And then when you are in that area where there is no sufficient or almost no evidence that Earth observation-based and AI-based systems can bring something, it's really a problem of missing these reference data. For example, when using the satellite thermal data for developing a system that monitor temperature of transport infrastructure, roads or rail, we need actual measurements to train the models, but even more to validate the models. There are out there some open data sets, maybe not surprisingly more for American, for example, railway, but not for European, because treating of these sensors in Europe and America is different. In Europe, our infrastructure managers consider that as security sensor data, or so of higher security level. So simply, there are no open access data, and even there, they are very limited. So it's very important then to collaborate with stakeholders in these examples, such as infrastructure managers and other stakeholders that could enable access to data. But establishing that collaboration, particularly in early phase of development, is not so straightforward. And then we come to the situation, so in order to develop the systems, we need stakeholders and their support to provide the data. And then we need to improve our systems to convince them. And that is the biggest challenge at the moment. There are some possibilities. EUSPA is actually very much user-driven and have these possibilities to have the projects where the stakeholders could be included. But at the end, we need to find stakeholders. It would be nice to have a pool of stakeholders for particular applications who are eager or willing to give the data, if possible.
Yes, thank you very much, Daniela. Mahi, I don't know if you would like to add something on the challenges part. Maybe working on the experience you gather from projects you did for us. You worked for us an Agribit project, Space for Green, if I'm not wrong. These are projects that maybe helped you to, overcome these challenges. And then I will raise the question to the rest, but maybe you can respond with this perspective in mind. Yeah.
Thank you, Vasile. I enjoy speaking at the end because all of my colleagues have already said the main thing. So I can talk about feelings now. So I'm so enthusiastic with AI, to be honest. 3 years ago, when we were discussing about the main challenges in digital companies, it was finding developers. Do you remember that? It was so difficult, it was so expensive. It was difficult for us small companies to find the people to build those solutions, even if you had a dream and you thought that you could solve the agricultural issues, you couldn't find the people to do it.
But don't tell me ChatGPT develops now for agro
Oh, come on, you know, it does. Hopefully it will do my job. It already does it better than I do. When you ask ChatGPT, the 8 euros per month version, on what do you think the challenges on EO and AI are for agriculture, it gives you much better answers than I do.
I could do that panel,
Yes.
just asking
Yes.
ChatGPT,
Yes.
getting the answers,
Yes.
everyone, okay.
Yes, that
Good.
would be great. But I think what we are missing in agriculture, I cannot speak for the rest of the sectors. That I know, I think well. I've been working in agriculture for the last 30 years. And I think what we are missing is the mentality of data. And somehow the Commission and the work that it was done in EU, it took a lot of time and it didn't bring the right mentality. We are talking about data. Who owns the data? Who should be paid for the data? What is the legislation behind data? And this created, you know, a fuzz on data. And at the end, we give the taxpayers give so much money into building these R&D projects, but we are not obliged to give the data needed for my colleagues here somewhere. So in agriculture, you have issues like regionality, soil, things like that, and you need to find those data because it's an input and output model, and you cannot find this data because I'm not obliged when I did my campaign in Agribit or Apollo or Space for Green to give those data back to the community because data are protected, but at the end they are not useful, they are lost. And maybe they could be useful for all of you and the work that you have been doing for us as well. So we need to find a way to approach data in a different mentality nowadays. I was in a meeting, and I will finish with that. I was in a meeting 1 month ago. There was a great presentation from JRC talking about yield estimation. And this is something that our customers are really eager to have in a high, of course, accuracy level. And they want it for so many reasons, I don't even want to start talking about it, but it's really crucial. The JRC was doing it for the member states, especially for wheat. And I was in that meeting. Do you know how they validate the results of these models? With expert opinion. Expert opinion. So you say this farm or this country will have that amount of tons, and then you have the agronomist validating these results because you don't have the data. So how is that useful? It's not. So our challenges mainly are what my colleagues already said about the mentality of data and how you use data. The second thing is that there is no question mark next to AI. AI is here forever. It will change the way that we think and we work, and that's a good thing. But the dependency we have on AI, the dependency we build now on AI, is something that we should take into consideration. Because this is something that we have started to see as an opportunity, and that's great. And it creates a lot of expectations, and you have the dependency and the expectations. And the customers come and they say, okay, give me the optimal harvest window for my bees. Why can't you do it? AI. And you say, I need at least 3 years or 4, because this is the time needed to build a good model. So the expectations have to be handled. The dependency needs to be taken into consideration, but the truth is that we see this as a great opportunity to do things cheaper so that everybody can afford it, to do things better and to do things faster.
I thank you very much for your input, which I think triggered Conrad.
Yeah, I just wanted to comment again. We've all said pretty much the same thing, but you were coming back with the challenges. I think we have to remember that the value proposition here really is EO with AI, with all the data. It allows us now to really integrate all kinds of information, geospatial, non-geospatial. We saw it this morning with the digital twins, etc. So yes, we have challenges, but it's still really a big value proposition, and I think that's how we can come and sell Copernicus more in context with AI as well.
Conrad, now that you intervened, I'm going to come back to you then. Maybe talk us through about Future 4, Unicorn. The audience is not aware that you are participating in these projects and have maybe slightly different roles.
Okay. Yep, so we're part of 2 projects. One is Future 4, the other one is Unicorn. Both funded through EUSPA calls, so very close to the customer or trying to deliver something to the customer. On the one hand, Future 4 is more a policy-based project. We're looking at the EUDR, So taking into account regulation and how we can take advantage of Earth observation, AI scaled down to plot level where customers can take advantage of either where their logs are coming from, or for example, disaster and taking the wood out and using it as fuel, also from a risk perspective. On the other hand, Unicorn is more about disaster resilience. And there again, AI is helping out from physics-based modeling and risk modeling. So taking advantage of those types of solutions in order to increase the speed, lower the costs, and of course, therefore, bringing those types of solutions to the authorities or to the customers that need them most.
Okay, thank you. Thank you very much, Conrad. Fran, maybe I will back to you on the activities that you do with us, maybe the Julia project. I know you were also involved in Cassini. You followed up some activities on Cassini. If you can a bit describe your experience,
yeah, sure.
and how this maybe how these developments help the company evolve, let's say, and develop.
Yeah, so we are involved in several projects, even leading a lot of projects for both ESA and EUSPA. At EUSPA, we are members of the consortium of the Julia project, which is a project with the aim of leveraging both Copernicus and Galileo for public transport operators. We are the only Earth observation partners, so we are kind of leading this part. And we developed and implemented the Copernicus Insight Repository, which is a digital platform that enables PTOs, public transport operators, to do smarter decisions in terms of resilience for public transport networks, especially in terms of air quality, climate change, and climate forecast. So what we are doing there and how we empower them is that we don't only try to create, like, you know, time series, monitor the air quality, generate indexes, but we try to go further, and we even give them recommendations on how to use the indicators, because you can have the best AI models, which we are using to downscale the pixels and the resolution of CAMS and Sentinel-5P using IoT data, actually open datasets for IoT and air quality data. But we give the user recommendations, because at this point we need to push and to actually educate our users in how to use this Earth observation data. So for instance, depending on the air quality, we give recommendations on increase the fleet so passengers are not exposed to the bad air quality conditions. If we forecast like a heat wave, same, increase the fleet, people are not exposed to this heat wave. You can even put for free transport. So we try to go further and to help users to understand and use this information. This is on the part of kind of chasing like the scientifically and technically excellence. But on the other hand, we have the Cassini Business Accelerator, which help us a lot in terms of go-to-market strategy, user engagement, how to find our GCPs or users, how to know which pain points do we need to solve. So it's not only about, again, having this scientifically excellence, but to know how to market, how to create and develop lovable products that can be marketable at the end. And in that sense, the Cassini Business Accelerator help us a lot as a company to move our services, own operations, to our end users and make them, again, usable.
Thank you. Thank you for sharing this experience with us. And Daniela, from your side, I'm aware your participation in the Copernicus demonstrators that we run. Also, you were participating in the Spatra project, which I think relates to what you were discussing before on the railways and stuff. Can you give us a little bit your experience, how you use this project? Because for us, it's not only, and also for the Commission colleagues, the budget you get for the projects and how much of it, you know, helps you to really build some kind of commercial projects and bring them to the market.
Yes, we were really happy at OHB Digital Services that we coordinated Copernicus demonstrators for mobility, emergency, and infrastructures, so Lot 1 project. The main goal of that project was to show how the Copernicus data could be transformed into the practical solution for these application areas. And also the goal was then that we, with our work, help expand the user base for Copernicus data. So some of you, I think, participated in lot 2, if I'm not wrong, so maybe familiar with Copernicus demonstrator projects. So it was organized in 2 phases. In the first phase, involved companies analyzed the feasibility study of using Copernicus data in 5 innovative use cases. And then in the second phase, 3 selected demonstrators were implemented in operational environment. And one benefit for all involved companies and us also as a company who coordinated was that stakeholders, it was easier to attract stakeholders because of this framework, project framework. Simply it's more believable for them. There is a funding and that they would be, could be involved. And also we as a company really gained experience on the benefits as well as limitations of using of Copernicus, so open access data in to build the near market, first near market services and then more so market services. And that I really like that this EUSPA framework to have this diversity of application areas, because in 2 lots were 10 different use cases. So to understand actually what is the difference between application areas, but what is also connection. And one topic was monitoring of infrastructure, which is directly connected to Project Spatra that you mentioned, that we are also coordinating. And within the Project Spatra, we use the satellite data and AI as a tool to develop innovative services for road congestion monitoring and for railway temperature, rail track temperature monitoring. So in all these, our goal was or is also in other relative ways to work with the innovative use cases and to come up with some possible novel products. And using of satellite data in of Earth observation data in transport is used. I mean, there are navigation data and Galileo data used, but Earth observation data not so much. So we are happy that in Spatra, with Spatra, we contributed to a broader use of Copernicus data inland transport, road and railway. It was a short project, only 2-year project, but thanks to strong support of stakeholder. In this case, it was Serbian Railway and NELT Logistic Company. We really managed to develop and to demonstrate in operational environment the benefit of services. And we hope as a company that we will go forward.
They will buy it. I hope they will buy it.
Yes,
that's the reason. That's why
yes.
we do the projects. Thank you, Daniela. Betty, on you mentioned about the geopolitical environment, and I think we talked about a lot environmental application, agricultural. I would like to ask you about the project HaDEA, because I know it touches upon security applications. Can you give us a little bit your experience, how AI is used in HaDEA?
How AI is used in HaDEA. Just a few words about HaDEA. HaDEA is a project that focusing on immigration flows. When we submitted this project, it was just one war in Europe, and also we had immigration flows because of climate change. These things have not changed, means that we will have in Europe immigration flows because of climate change the next years. But now, for sure, with the second war, it is assumed that there will be enlargement of the flows from this geopolitical situation. In the HaDEA project, we use multi-source fusion. So based on that, we start off getting advantage of the Copernicus strength and the Copernicus contributing mission, but the idea is to build on top of the Copernicus security service. And this is the key point, because in our project we fuse also major information from national missions. Some of the European countries, 4 of the European countries have ongoing missions. One of those is also Greece. And we have the possibility to use, even at this moment, because we are in month 15 of the project, which is going up to month 30. It's a short period project because we are a commercial company and we submitted this project in order to get new products on top of products that the company already has. And by getting information from the imagery from the national missions, there is an extra strength because most of the national missions are working with microsatellites. Another asset that we are using in the multifusion is the use of satellite video. There is one unique national mission in Slovenia, HD, which is a satellite video. It's a microsatellite. Slovenia is a very small country, but by using this information southern of Cyprus, we get valuable output by using artificial intelligence and, of course, Earth observation, pure algorithmic tools. And, of course, we have also in situ information, and like that, we can have the correct validation. As add-on to those, for maritime purposes, we also enhance the system with information of AIS, automatic identification system of the boats, that they have it open because the dark vessels, they don't use it. And in order to have one step ahead, we involve also RF data. For that, we had a very big problem in order to get RF data because of the GDPR, but our interest was only the geographical concentration of the data. So with the help of the legal team of the company, we finally achieved this task, because it was really a big task to convince that we are not getting real information, personal information. And some evaluation of crowdsourced data too. So this multi-fusion of data, which is not only Earth observation, gives possibilities to better use of machine learning and deep learning tools, and to serve with a platform to the end users about the migration flows. When we submitted the proposal 2 years ago, the immigration flows estimation was that by 2050 we will have 200 billion immigrants, new immigrants, coming to Europe because of the climate change, not because of geopolitical conflicts. Now think that this 200 billion...
Billion or million?
Billion.
Okay.
Million.
Million, yes.
Million, sorry. Million. So 200 million immigrants for climate change, because of climate change, which is an issue that is still there, will grow because of the geopolitical situation. What is giving us some extra strength to the THEA project is that from inside we have information from the entrusted entities. As partner, among others, we do have also SATSEN, that by having SATSEN as a partner, we have concrete information, and by working step by step in the use cases, because there is a kind of guidance for the differentiation of the use cases, and this multi-fusion and machine learning, deep learning use, we can at the end act as a facilitator to the decision maker.
Through the established Copernicus security service entity, let's say. Okay. Now I would like to ask about an aspect. I had in the morning an exchange with my daughter, 9-year-old on WhatsApp. So I thought about the question I wanted to make, but it fits a bit with the questions I would like to share. She asked me what I'm up to. I'm responding. I'm listening to a talk, then we'll go on stage and present and have a panel discussion. So it's like, oh, interesting. We'll discuss about AI and how the companies use it to do stuff. Oh, I did that in the challenge zone. This is a thing they do at school. Cool, you could have come to present with me then, I'm telling her, Lydia, 9 years old. All the way to Brussels, yes. Do you have something that I can share with the crowd? And she goes, sometimes AI doesn't know the answer and makes it up. So that's a good, that fits with the question on risks. So I wanted to ask about the risks. A little bit from the previous answer, you talked a little bit about this aspect, but particularly with maybe you, Betty, that we're discussing more sensitive application. What is the risk there? How do you deal with it on building, let's say, an algorithm that does something that is sensitive? So, you know, what is it? A human in the loop approach? What do you do particularly for this kind?
In my point of view, everything that is automatic gives a risk. Your daughter is very clever, I could say. We think that in order to produce something that can be used, we have to take as first step the use of artificial intelligence, but the models that we shall make have to be done in a process that we have ground truth and information because of the specific application, cannot be application agnostic. Also, the sensors cannot be agnostic. We have to choose the correct data for our application. I'm not speaking only for the THEA project, but also in general. And when there is always the involvement of citizens, civilians in general, we have to double validate the output and just to use it as an enabler, a facilitator, not get it as a decision, a final decision, and give it like that to the decision makers. Because there are so many implications around, and we are speaking for humans. It's not something which is like, I don't know, this table. We are speaking for humans, and this is very, very, I mean, we have to think as responsible citizens on that.
No, what you're describing is kind of having always some kind of human, as I said, in the loop, so that you pass the information validated before by someone who is maybe expert in this specific field that we talk about. And
for sure, we get help from colleagues that are qualified on photo interpretation, analysts, before putting everything in the, let's say, system, and this in several steps, not in one step.
Risks. Mahi, I see you getting ready for...
Getting a little bit, you know, this is my husband, you know, like AI. Typically, he doesn't know what he's talking about, but he gives a response. In 2005, no, come on.
Let's keep that.
In 2005, I think, I was in my first year of my PhD, and I had to be introduced to the teacher in the school that I was, I'm an agronomist, on statistical analysis. I went to his office. I did, at that moment, I did SPSS and DEA. And he told me that everything I got from SPSS, I had to do it by hand as well, because machines do mistakes. It's like humans don't. Okay, come on. Yeah, it's just starting. Yes, maybe ChatGPT doesn't know everything. Maybe DeepSeek is better in text. Maybe Copilot does better work on that. But it's there. This is what we will live with. And going back and saying that it doesn't know everything, we don't know everything. Okay, it's not about replacing. In some cases, it does replace. But it's not only about replacing, it's not about talking with fear about AI. The things that we have been doing in the company in the last few years with machine learning in the beginning, it was amazing. The service that we gave to our customers would never have been done if it wasn't for that, for us at least. Yes, we will be careful. Yes, we will be responsible, but with everything. It's the same thing. So I think when we talk about risks, then of course it's good to have them in mind. We don't go without having them in mind, but this goes to everything that we do, having a risk management plan.
This is very useful. Now, it brings us a second question. Do you factor in the feedback you get from customer? Do you build so that when the customer sees that, okay, this I don't know, measurable quantity that you tell me here is not correct. Okay, this yield estimation that you do is not correct, or this whatever.
They
NDVI
don't care if it's AI or not.
Exactly.
So come on, they don't. Do you? When you get something from your bank, do you care what tool they used in order to come up with the result they give you?
It's behind, it's on the background.
Yeah, this is behind. This is always behind. So what they care is, do you give them something that's useful? It saves money, it saves time, it gives them better quality, it satisfies whatever need they have, and can you give it in a price that they can afford it? Does it bring value? And this is, I think, the only question that we have to make to ourselves. Because when I say, in the beginning, I said that when we started in the company, we made so many mistakes. And the mistakes we made was that we were not focused on the market. We were not focused on our customers. We thought we had answers based on technology.
True.
And then we came up with less innovative solutions, because when you go to EU-funded projects, then you have to take the boat and land it in the moon.
And show some innovation.
Yeah, so some innovation, and this is very good, because what you pay us to do is high-risk innovation. And this will go out to the market in 5 years, in 6 years, and you have to stay alive until that time. The first time that we did crop type mapping, it was, Erwin, it was 10 years ago, 8 years ago with Yanis, crop type mapping, the first time that we did it. And it was not even allowed by paying agencies to deal with this subject on Earth observation. And now we are doing it for our customers. 8 years later, we managed to survive, we managed to stay in business, but this is what it is.
Good, yes. Daniela, Conrad, maybe later. And
sorry. So, yeah,
no, we keep your husband out of the discussion.
Out of the loop.
So I think we cannot generalize risk. We cannot say risk of artificial intelligence. This really depends on application to application. When something is safety critical, then customer will, for a long, not use AI-based. So when something needs to be certified, question when it will be possible. But when it is not safety critical, I like what you said, customer likes better solution. And completely this example that I gave, using satellite data to measure the temperature of rail track. Infrastructure managers nowadays mainly use weather forecast and then to offset that. Weather forecast is also uncertain, and meteorological station is far from rail track. So if what we need with AI systems to do is certainly uncertainty, to always give in a package uncertainty report, or to be clear what is uncertainty of our system, and if it is better than uncertainty of current, then why not? Yes. Yeah, sorry that I...
Yeah, I mean, I liked what Maki started with. We're trying to run a business, so if we can sell it to the customers for cheaper, for better than our competitors, then that's good for us. AI is helping us do that. Now, if I put my geographer hat and sort of think of AI and map making in general, If you look at EO when it came out, even 40 years ago with Landsat, hey, it was expensive to create a map. Today, everybody makes a map because Copernicus is open. What's the quality of that? I don't know. Verification, quality control, that's more expensive today. So if we can get away with AI and give the customer what they want, then we can do that. But I totally agree. We need to keep track and verify what we're delivering.
Thank you, Conrad. Fran, maybe.
Yeah, I mean, I think that we are quite of been focusing on the AI part. I mean, and it's obviously quite important, like how we validate the results, how we do like back testing and whatever. But I think that we also need to go further. I mean, for instance, at DEFIS we are training as we are actually giving a service. We train a model to calculate car accident risk in roads. And at one point, okay, we have to train the model, we'll validate it and everything else. So the model gives like a probability from 0 to 1, but this is not usable for the user, okay? So we characterize and we create categories of risk from low to critical risk. Okay, that's another part that's more usable. But then we wanted to go further and we said, okay, with the user, we are going to build how to use like the decisions we are going to make depending on the outputs of the model. So for instance, if it accumulates 3 hours of critical risk, we are going to put these actions, maybe moving a patrol, maybe putting some panels or cards, but we build this with the user. So we make the user able to use the outputs of the AI model. So I think there are different parts. So on the one hand, we have the AI. Obviously, we need to validate, we need to do historical validation, back testing, all of this stuff that we know, but we also need to go further and to help and to create this business and these decision-making processes with our users. And I think it's a way also of smoothing the results, also making sure that, that we are responsible and that the risks of the AI are kind of mitigated.
I would like to thank you for all your inputs. You know, during the discussion, the flow took us in and we are quite, I would say, late because we have something to show and maybe even take questions. I would like first maybe that we show what we have to show, and we have some videos. I hope they will play. And I think the first one is your video, Fran, that you brought us. Let's try it. There you go. Yep. What do we see? Well, we'll click play and then maybe you can narrate on top. Yeah.
Great. So this is the Copernicus Insight repository. We deployed 4 different PTOs and cities across Europe: Roma, Sofia, Budapest, Thessaloniki, and so on. Here we have the air quality panel where we are monitoring the air quality index and different air pollutants. But here comes the important part where we put recommendations for PTOs, for cyclists, for general population, on which are the current status of the air quality. Then, obviously, we also put the air quality index forecast in the coming days, and we can move from the air quality index to transport-related pollutants, because, again, this platform is focused on PTOs, on transport-related public transport operators. So we have the different transport-related pollutants. We can even filter them if we want to see one of them. We have the different sources here, again, for trustability. Historical data, the historical air quality index for this city. Again, we can change to transport-related pollutants or pollutants. So this is simply for information, for the business intelligence of the users. And then here comes the AI part. So we have this information from CAMS, but we don't scale CAMS Sentinel-5P using IoT data. So we created high-resolution air quality maps that can be used for NO2, CO, CH4, and so on. So this is still under development. Then we have the climate change part, where we monitor historical climate change data and climate change indicators such as max one-day precipitation, frost days, frost nights. So this can be used as a strategic planning for better planning for the infrastructure, and then the weather forecast for total precipitation and for temperature. So this is what I was saying. So PTOs can use this kind of information to predict a heat wave and mitigate the effects that the passengers can be exposed to these kind of climate events.
Excellent. Thank you. Thank you, Fran. So AI in action. And then we have the second video. Maybe we can put the second video there. I'll ask you, Conrad, maybe to explain to us what you've brought. because I see the second is on risk cognition.
Okay. Just to give some background before it starts. So I just decided to pick a few workflow elements that we're integrating from an AI perspective. On the one hand, the first one that you're going to see when it starts is let's say the traditional EO solution. So you have an expert looking at an EO image, and in this case, we're delineating or detecting and clustering hotspots. So this is to understand whether it's a wildfire or not, and how it's evolving over time. In the next one, we're actually delineating the burned areas. So, sorry, just to give some background here. These are thermal anomalies coming from the different satellites, multiple overpasses during the day, and we need to keep track of what's happening. Then we need to map. So here is just about delineating the extent of the burned area. So just similar to how an expert would be doing it, we get the help from AI. And of course, we can use multiple models. We don't need to use just one, but it's sort of like having a whole team working on the same problem, and then we see it. Another aspect is knowledge graphs. So a good analogy here is AI will understand what a building is, but if we can integrate then other types of information through a knowledge graph, it will then also know how many apartments there are inside, who's at that address, whether they have any issues, and through these relationships, we can increase the way the AI understands the object itself. And finally, LLMs. You heard ChatGPT, but now we can use the LLM to take advantage of the user's questions, and it will create the queries needed, for example, for a knowledge graph query. So we don't have to do all the back work. We don't have to pre-formulate, let's say, queries for the user. They can use the large language model, and it will translate that into viable queries. Thanks.
Excellent. Thank you. Thank you very much, Conrad. I think the third video is yours, Daniela. Video number 3, Spatra. Maybe you can...
That is Spatra, about novel use of satellite data and AI in monitoring of railway infrastructure. In Spatra project, we develop a system to support fighting problems caused by extreme temperatures, such as deformation of rail track, for which is necessary to measure the temperature of rail tracks. And we believe satellite data can help to overcome problems of standard or conventional measurement. We have 3 steps in our system. In the first, we improve the resolution of the land surface temperature data. Then that improved data is used as one input to AI model to predict the rail track temperature. And that predicted rail track temperature is used at the first step to estimate the risk for buckling, for deformation of rail tracks. For that, we needed, of course, data and had support of Serbian Railway. We managed to do that data generation on 14 different positions and to train our models. And here you can see graphical user interface. The Serbian Railway network sessions are overlaid over the map on considered area. After selecting the date and time range and selecting the rail track section, it is possible to display the predicted temperature for 24 hours in the future. And also, it is possible to display the risk of rail buckling, of deformation of rail tracks for the whole network, as well as for the selected section. And here you can see 25th of July, where the temperature in Serbia was about 50 degrees or 60 degrees of rail track, because outside temperature was 40 something, and the bad buckling happened that our system could see. So the infrastructure manager could use that to better estimate when it's needed to slow down the temperature of trains or when it's needed to close some section. Nowadays, they are using that by default. Outside temperature is 40, I'm closing, but with our system, they can more precise estimate when it's needed to do some action or if it's needed, yeah.
Okay, thank you very much. That was Spatra, right? Yes. Betty, maybe the video number 4 is on Thea, or Thea, how do you pronounce?
Correct.
Okay.
As I have already informed, it is a project that has a consortium with multitasks, including also SATSEN. We have specific objectives in order to improve the existing Copernicus security services by multi-fusion data, and also to define with the help of the entrusted entities what's missing in the Copernicus security services, and with the use of GeoEye to have the possibility to enhance the tools and processes that the decision makers shall get, but not only by using AI, but also with very good ground truth and very good validation of the solution in different cases. One case for sure, it's the illegal vessels coming from around Europe to Europe by using specific routes. We have also tried to define with the help of SASEN if these routes are continuous using in order to better define the risk. And of course, as I have mentioned, we are trying to use also satellite video. And last but not least, to identify what kind of object is the one that is monitored to in order to give the information to the decision makers. As I have already informed, we are in month 15 and it's 13 months project, so we don't have a finalized front end in order to show how the platform will be. We will first demonstrate it at the end of April to the entrusted entities, because also we are working with the Frontex Copernicus people in order to see what is needed to be changed in order to be fully operational and used from all of the entrusted entities.
Thank you. Very interesting. And you are in the middle of the project, right? You said 15 to 30. Okay. And the last video, Mahi, you brought number. Let's see.
Now, the best is yet to come.
I hope it's not your husband on a video talking.
No.
Okay. Agrabs.
Nor your daughter. Yes, it's Agrabs and the fantastic applications that we have and the more fantastic service that we give to our customers. So we started working with this platform like 8 years ago and still work in progress. But it has managed to build many, many services for many crops. We started with 2 crops in 2 regions, and now we have almost all crops. So this is how the platform works. One of the things that we did in the projects that we discussed was to give a pest and disease alert so that the farm does not proactively go to the field to spray, but they have the forecasting ahead of them. The second thing that was very important was to understand the grain protein content, and this is very important for specific industries on how they are going to, let's say, organize the things that they have to organize with respect to protein for pasta makers and beers, etc. And the third thing is, which is a work in progress for the community in general, is yield prediction. And for that, we keep on working with our partners. We keep on working in projects and customers, because this is something that, as you understand, it's crop specific, soil specific, variety specific. It's very difficult, but it's really important for the agri-insurance scheme, for governments and ministries, for customers themselves in the agri-food industry. That was very good.
Thank you very much. It was all very good. So at the end, we had a little bit of action in the AI in action. We have some time maybe to take questions, if you have questions that you would like to raise to the panelists, or if we have something online. We could have left a bit more time. I know you're tired, please. We have a microphone in the room. Otherwise, I will come down and maybe give it. Thank you.
Thank you. Thank you very much for those nice illustrations. I have a question. This is a general question, but I will take the example of air quality. I'm Laurence Fries from ECMWF and CAMS. So this application based on CAMS data and CAMS forecast, I guess. So this true. This is what you say. This is not a time series. This is not the usual air concentration maps that we produce. But I was wondering whether there are some additional added value products that would be useful, that the services, the Copernicus services could develop, not only time series or maps, to help you in developing further this kind of application. So you've mentioned the air quality index. Is it something, gathering this information to elaborate an air quality index, is it something that would be useful for you to develop further your added value products? I took this example of air quality, but I guess that this is it can apply to all the services and all kinds of applications.
So if I'm not wrong, the question is which other services, Copernicus services, can improve these applications we shown? That's a very good question. I mean, we can think like in a lot of different use cases. One Copernicus service we wanted to include is, for instance, land monitoring, because there is one interesting service which is I don't remember the name, it's about the ground motion, the INSAR service. It's also which is also very, very interesting because of the railway monitoring, road monitoring. At the end is critical infrastructure. It's kind of difficult to integrate in an operational way, as if you are aware of how INSAR works, it's kind of, yeah, difficult to interpret. But I mean, the use cases and applications are like endless. So in this project, we wanted to scope and frame it because the goal was to educate the PTOs, public transport operators, in Earth observation data. They didn't even know that weather data and air quality data comes from satellites and from Earth observations. So this was one step. So we prefer to go step by step. First go air quality, then climate, and then we can try with other use cases. But we prefer to start small and then add more value. But I mean, again, the services you can use are endless. So there are a lot of different applications we can use there. I don't know if anyone else wants to add something.
Sorry, I just wanted to give a quick shout out for the Copernicus data space, definitely improving the access to Sentinel-1 and 2 and 3, and EUMETSAT as well. Those types of services where companies like us can access the APIs and just get the data much faster and much cleaner from a developer perspective. So not geographer hat, but developer. That's the kind of thing I think that needs to move forward.
Thank you. Thank you for the question, and that was a good input as well. Chiro on the back, I can see. Maybe we can take one last one, because I guess we are all hungry.
Thank you. So this is Ciro Farinelli from Airbus Defense and Space Connected Intelligence. So very interesting topics. I was wondering, for the training itself of the services, do you guys use only open and free data, or do you also use very high resolution data? Thank you.
We mainly use very high resolution data. That's why I mentioned the Copernicus contributing missions and the national missions. For the specific case, we mainly use European data because it's a sensitive operational service, and we prefer to see if with the use of European data, we can achieve the results that we wish to have in order to have a kind of European independency on the data fusion.
We try to use only for validation high resolution data, not for training. So to develop something affordable and to help us during development for the cost. Yeah.
I mean, we use very high resolution data, but not as much as you wanted. So I encourage you to, if you want to open or share with us sample of dataset, we'll be very, very happy to train models with them. So at the end, this is your business, I understand, but it's very difficult and expensive to train very high resolution models with this data. And users ask for that all the time. So Copernicus sometimes is not enough. So again, I'm very happy to collaborate in that sense.
Yes, for us in agriculture, it's not in some crops you don't need them, but in some crops you cannot work without. 10 by 10 from Sentinel is good for cotton, is good for wheat, is good for many crops, but when it comes to vegetables, when it comes to other crops, you cannot work with them, so you need them. It goes without saying. So it depends.
I think if we'll allow it to be as a question.
Yeah, we also have a lot of questions from the online participants that also can be via Slido. And I would like to quickly pick on the questions on SMEs. And first one remark to Betty, there's high interest in your latest report and the statistical data, so we should provide this link. But the main question for discussion is really on SMEs. And the question is, would the current challenge faced by SMEs be linked to or caused by consolidation of market towards the bigger players who can afford large data and HPC infrastructures?
Okay, I will go from the last word, HPC infrastructures. In the latest period, we see that there are some governmental HPC infrastructures coming out to give availability to Europeans under specific fees that it is assumed that it will not be the Amazon fee, it will be something better on that, because these infrastructures are coming from recovery fund and citizens taxation. So it is supposed that this will give to SME a kind of extra help in order that all those services to run in a proper way, but with not an extreme cost, because an SME cannot have a big infrastructure at, like those at the office. So starting from that point, I see that in Europe, in the next period, we will have more and more such establishments. And the question about the cost of the data, correct, was the question before. Okay, commercial providers, and in Europe and outside Europe, they have specific price list. This cannot be changed because it's commercial providers. So based on that, the need is to evaluate how much you need to buy from a commercial provider, how much you need to use Copernicus Sentinel data, and how much you can use the national missions, but in the cases that those missions are accessible to the SMEs. So there are 3 points that for every application shall be calculated in a good sense in order that the application to be commercial served to users, and to have a benefit means not a loss, not break even, but a commercial benefit in order that the SME continues to grow.
If there is any other question online, we can maybe take it. Another one, last question, otherwise. The AI is thinking.
Yeah, maybe another interesting question then to EarthPulse. Question is the application you had free to use for public authorities, or who are the key stakeholders?
Yeah, I mean, the application right now is open, so anyone can access this application. Obviously, if you are a policymaker or a stakeholder from a city which is not involved in the project, maybe, well, you won't have data. But right now we are in an open call, so if any PTO, any city wants to join the project, feel free to submit. So this is one thing we were discussing with the other partners. So again, in this project, we are leveraging Copernicus and Galileo. Galileo partners needs to install hardware and so on. And we said, we don't really care. I mean, we just need like the coordinates, the bounding box, the city, and we can implement the system anywhere in the world. This is the value proposition of this data, you know. So yeah, so this will be the point.
Okay, thank you very much for the questions online and also the ones in the room. I think I will conclude here also because it's lunchtime and we are a little bit past the time. Thank you very much for the contribution. We had a very interesting discussion I wasn't expecting, so please give a round of applause to our panelists and thank you very much.
Okay, good afternoon. Welcome and thank you for being still here after 2 intense days. I have the pleasure now to open the session on research and innovation. These 2 days we have heard a lot about the use of AI, the application of AI, but no application would be possible if there was no research behind it. So we have now a panel with first an introduction from, sorry, I'm waiting for people to come in. Okay, so I was saying we have now a session on research, the research that supports AI for Earth observation. I have the pleasure to invite on stage Marko Curavic, who is the head of unit of the Space Research Unit of the Health and Digital Executive Agency. After that, we will have a keynote speech and a panel with a few distinguished panelists. So Marko, please.
Good afternoon and welcome also from my side. So HaDEA, or unit before of HaDEA, Space Research, is one of the co-organizers of this workshop. And we are very happy to have such a large response, which is about 7 to 8 times bigger than we expected. Many therefore online. It shows the interest in the community in all these themes that we've been discussing today and yesterday, and also the relevance. So before we will have this panel kicked off and the keynote speech before, allow me to just say a few words about the Space Research Unit of HaDEA, the Health and Digital Executive Agency of the European Commission. And you will say health and digital, it starts with health, but there is the digital part. So HaDEA, as it's called shortly, was established in 2021 to implement, among other things, the Cluster 4 in research of Horizon Europe. It's digital, industry, and space. So we are part of that cluster, and this is why we're in HaDEA. And when you read the name, focus on not the H, but the D. Actually, our unit has been around before the establishment of HaDEA, since the end of the 0 years, 7, 8. We were most of the time with REA, where we were doing space research and covered a very broad range of technologies, applications, and among them also Earth observation and research in support of Copernicus. So the unit's work has been around for almost 20 years. And in the field of Earth observation, we started in FP7, so some of you remember FP7, some of you did other things before FP7. But those who remember FP7, 2006 to 2013, we started with the large integrated projects that laid really the foundations of the Copernicus services. And by the way, I mean, those who have followed it, you know that we got a lot of recognition for Copernicus as a European achievement, and even NASA said that this is the best Earth observation infrastructure that you can currently find in the world. So after laying the foundations in FP7 through Horizon 2020 and Horizon Europe, we supported the evolution of the Copernicus services, also through research on big data and artificial intelligence for remote sensing. And I think you have all seen yesterday and today that this has actually become more and more important and is or will be the focus of the future, because the advantages that are offered are really significant and help us to get more out of the data in a shorter time at lower cost, by the way, also. So in our session today, we want to have a very open and frank exchange of view with some of the most prominent researchers in the field of AI for remote sensing. And this is why we have selected a panel of distinguished experts involved in EU-funded projects, not only from HaDEA, but also from some of our, as I call it, sister units in different entities of the EU, services and agencies. Now, before engaging in a panel discussion, which will be moderated by Massimo, I would like to introduce to you Professor Begüm Demir from the University of Berlin. Wait, I will introduce you with your CV and so on, and then you can come, or you can sit down, as you wish. So, Professor Demir is one of the most prominent researchers of today on AI for Earth observation in Europe. She is a full professor at the Technical University of Berlin, and she's the founder and head of the Remote Sensing Image Analysis Group at the Faculty of Electrical Engineering at the TU of Berlin. She's also head of the Big Data Analytics for Earth Observation Research Group at the Berlin Institute for the Foundations of Learning and Data. So mostly what she is focusing on is an intersection between machine learning and data management for Earth observation. And she got in 2018, she got the prestigious 2018 Career Award by the IEEE Geoscience and Remote Sensing Society for her research in machine learning for information retrieval in remote sensing. She also received one grant from the European Research Council, again our sister institution, so we are happy and proud, for her project Big Earth, Accurate and Scalable Processing of Big Data and Earth Observation, again in 2018. And this year, again, for a proof of concept grant from the ERC for her project Agent Big Earth, an AI agent to support environmental intelligence by interacting with Copernicus Earth observation data. Professor Demir is an IEEE senior member and fellow of the European Lab for Learning and Intelligent Systems, ELIS. So I guess we couldn't have got a better speaker than you. Thank you, and please let us know what you think.
Okay, thank you very much for the very nice introduction. So hi everybody, it is my great pleasure to be here to talk on recent trends in AI research for Earth observation. Next slide, please. Okay, so as we have heard, as a result of advances in large language models, nowadays there are so many AI assistants that can help the users to engage in a dialogue for several different applications. Such applications can be about supports, can be about software development, coding, so on and so forth. But are they really successful for Earth observation problems? Now I will be showing you an example. Okay, yeah, thank you. So here in the slide, you see a Sentinel-2 image patch, and on the right, you see the reference map. And as you can see from the reference map, the area includes different types of forests, like broadleaf forests, coniferous forests, mixed forests, inland water, and arable land. So we asked to GPT-5 to caption this Sentinel-2 image, and the caption is very generic. Like, this image appears to be a satellite view of green vegetated area. Surrounded dark to medium green areas indicate dense vegetation or forested land, so very generic. So I think remote sensing researchers can be in agreement with me that if you are interested in analyzing forests, detecting different types of trees, GPT-5 will not help you for that. Why this is happening? This is happening because these assistants, these models, they are not trained for Earth observation problems. They are not trained by seeing huge amounts of satellite data. So they can produce these high-level captions. And for that kind of caption, that kind of text, you don't need Sentinel-2 data. It could be also generated from an RGB image. So what could be the desired text for such an image? Yeah. Next slide, please. Okay. So for example, it could be very good if the caption includes land-use, land-cover class information and also the spatial relation among these classes. In addition, it could be nice to have like the size information of the area covered for each class, climate zone information, location information, so on and so forth, okay? But current assistants, general purpose assistants like ChatGPT or so on, is not capable of doing that. And to address this problem, we have designed and developed a new data set that we call BigEarthNet text. Now I will be providing you short information about this data set. Next slide, please. Okay, so BigEarthNet text includes Sentinel-2, Sentinel-1 pairs over 10 European countries. And in addition to pairs of images, it includes a caption, long caption, that explains or that describes the information present in the data in terms of land-use, land-cover classes, their spatial relations, so on and so forth, and also question-answer pairs. So for example, for this image pair, we developed the question like how many areas covered by urban fabric can be seen, and then multi-choice answers are there. The output is, for example, in this case, 3. It also has questions with yes-no answers, like are there regions of the coastal wetlands in the satellite image, for example, and the output is no. We also have questions that require to predict bounding boxes around the class. For example, what is the relative position of the arable land to inland water? And there are multiple choice answers. The output is A, for example. Or what can be the largest patch of urban fabric to be found in this area, for example. So this data set includes almost 500,000 Sentinel-2, Sentinel-1 pairs, together with almost 10 million textual descriptions, okay? So how we generated it? I will be giving you a brief information about that. So to generate this data set, we use the images from our BigEarthNet data set. So that is the data set with more than 30,000 users already, but the publicly available BigEarthNet data set includes Sentinel-2, Sentinel-1 pairs. Currently, the textual text data is not public, but we are planning to release it in few months, not few months, sorry, few weeks, because we submitted the paper last week, so it's quite new. Next slide, please. Okay, so BigEarthNet has a huge amount of users, and we think that it helped to our community to design and develop AI models that can be operational on Sentinel-2, Sentinel-1 archives. Next slide. Okay, so to generate the text, we took the BigEarthNet images and maps. Here we use the Corin database from 2018 as the land-use land-cover maps. And now from this map and the data, we first generated template-based captions. Okay, in terms of the presence of the classes, relations of the classes, we extracted this information from the map. And then we asked to an LLM to increase the diversity in the caption. Since our starting point is the data and the map, the template-based caption is quite accurate, but then we asked the LLM to increase the linguistic diversity. And here we use the Llama model. So then from this caption generated, we also design and develop question and answer pairs, several different of question and answer pairs, and the bounding box information we extracted from the Corin map, okay? So according to our knowledge, at the moment, this is the largest image text data set driven from Sentinel-2, Sentinel-1 data with good accuracy, which depends on the coordinate map quality and the templates, of course. But what we did is that a small set of this data set was manually checked, and we will be also releasing this set that you can use as a test set. Next slide, please. Okay, so then here in this table, you see very interesting results. We train a model, a very well-known visual language model from the computer vision with our BigEarthNet text data set, and then applied 4 different downstream tasks like captioning, binary visual question answering, multi-choice question answering, and so on. And then we compare the obtained results with the state-of-the-art remote sensing visual language model and state-of-the-art computer vision model, okay, under different downstream tasks. And for example, for one of the tasks, the best model was GPT, okay? So, and then as you see, the improvement is huge. So for example, in the binary VQA task, it is 10% improvement with respect to state-of-the-art computer vision, but with respect to reference expression detection, that is mainly creating the bounding box around the land-use land-cover class, the improvement is more than 30%. So this is a clear sign that if we would like to make use of this existing assistance for Earth observation problems, there is a need for post-classification or post-processing, or you can call it like fine-tuning, okay, with the proper data, so that these models can understand our problems. And BigEarthNet text is just one way of doing this, and currently it is on 10 European countries. Of course, we need much larger than this. So if you would like to create a large language model or visual language model that can be understanding several different use cases for Earth observation and that can interact with the user, communicate with the user under different Earth observation problems, we need such data sets, okay? Next slide, please. Okay, so can we go one slide back? Okay, so we have heard about foundation models during these days, and there are so many foundation models in remote sensing at the moment. Image-based foundation models, image language foundation models, the number is huge. And currently we see, in terms of research and development, 3 different directions. One direction is scaling up the model size and training data. Second is the architectural innovation, so developing new models. Third is integrating multiple data modalities, like Sentinel-2, Sentinel-1, Landsat, hyperspectral, so on and so forth, okay? And then, of course, we need architectural innovations to characterize all this data together, okay? But there are already many models, okay? So around 160, according to our last check. Next slide, please. Then the question comes, if you are an end user, and if you would like to just make use of this foundation model, which one is the best? So that question was asked yesterday in one of the last panels, I think, and also today, similar question, like how I can select the best foundation model for my downstream task. So that is challenging because at the moment, we have this information about these data sets through their papers, scientific papers, model cards, or Git repositories, right? So usually the evaluation is done manually. What does it mean? So you take your data set, select one of the benches available, or you just go without bench, but then you need to compare your results by applying different foundation models, right, to understand what is the best for you. So that is very time demanding. To address this problem, we vision, next slide please. We vision to have an agent, to develop an agent. Imagine like you are interacting with an agent to select the best foundation model for your downstream task. So here, this is just an example that user is saying, I want to map different crop types in Africa. I have some Sentinel-2 data and some labels from last year. Then the agent is asking the hardware setup. Do you have access to GPUs and so on? So then with back and forth communication with the agent, we thought it can be cool if the agent is proposing a foundation model to the user. Okay? So then that was the beginning, how we got this idea a year ago, and now we have an agent doing that. So next slide, please. Okay, So we call it as REMSA. So this is remote sensing model selection agent. So user interacts with the agent, tells the requirement, okay, the constraints, and the agent understands it. It has some communications with the user, and at the end propose the foundation model. So how it works? To make it operational without training anything, we thought it can be nice to have a database of foundation models so that the entries from user can be matched to those of the database, okay? With that way, we developed the first foundation model database in remote sensing community. Next slide, please. Okay, so this is a database of foundation model entries. Currently, it has around 160 foundation model information. From this QR code, you can have access to database directly. So it has all the information that one may need. So like from training parameters to downstream tasks to benchmarking results, model weights, all this information is now listed in this database, okay? And how we created it, it is a kind of hybrid approach. So it is a collaboration with an LLM and a human expert, okay? So we call different LLM calls, and we ask LLM to fill these places in the database, but then whenever there is a high uncertainty, our researchers manually checked it and corrected it, okay? So currently, although it is available, we would like to make it community contributed. Okay, we are currently preparing a system where whenever you have your foundation model, you can just enter the information there and it can be automatically updated by time. So that is our aim at the moment, that it will be community contributed very soon. And then the next step will be that we would like to include the foundation models from the other research domains too, like medicine and so on. Yeah. So our agent is relying on this database. Next slide, please. Okay. So it has an interpreter. Interpreter interprets the user input, so user just types what they want. And then the text is turned into a structured constraints about like task, modality, available data, deployment device, and so on. And there is the task orchestrator, okay, that manages the workflow and tool calls. So then there are 4 different tools. Next slide, please. So in the retrieval tool, the aim is to make use of the database, okay? So then the entries of the user are matched to those of the database entries, and the most similar ones are retrieved, okay? And then there is the LLM in context learning. This is for the ranking. And then there is the explanation generator tool. So then the agent explains why these foundation models are proposed. Then the clarification generator tool, because maybe the constraints, the text that user wrote is not enough, and then there should be some clarification needed. So then that tool is doing this. So REMSA is orchestrating all these tools to return to the user the most relevant foundation models. And you can ask, how do you evaluate such an agent? It's challenging because this is the first agent in the community for that purpose. And currently there is no benchmark data set in the literature available. So we created our own benchmark data set. We we constructed 100 queries. Like I want to do crop mapping. I have Sentinel to time series data. Which foundation model is the best for me? I don't have any access to GPUs and so forth. Okay, and we made this, and we asked 2 different experts to assess the first 3 foundation model suggested by the agent. Okay, and I will not go into detail about the results here, but the paper is publicly available, and database, all the code for the agent, everything is publicly available at the moment. You can take a look, and if you have any questions, we can discuss afterwards. Next slide, please. Okay, so we are very much interested in knowledge discovery systems in general. And supported by European Research Council, during the last years, we developed methods that are providing foundations on knowledge discovery systems for Copernicus data archives. We mainly target Sentinel-2, Sentinel-1 data, and we wanted to work on turning into our methodological developments, so turning our methodological developments into an innovation, yeah? Because we develop image search and retrieval methods like query by image, query by text, as space agency is called. And then we wanted to orchestrate all what we develop for that purpose via an agent. And that is the proof of concept project that we recently get, and it's called as Agent Bigard. Now I would like to just mention very briefly about it because it just started, and here we are targeting 2 different use cases. Next slide, please. And the first use case is for the policymakers. Like, imagine like a policymaker is asking, can you find the most relevant images from the Copernicus data archives to help us to monitor the road conditions in Spain? So that is a problem of text-to-image retrieval. And through this ERC project during the last years, we developed many text-to-image retrieval methods, and now we have the chance to make it operational via an agent. And then the agent will be using or will be orchestrating our methods as different tools, and then will return the images queried from the Sentinel-2. So let's say, yeah, from the Copernicus data archive. And then policymaker can also ask, can you quantify the decline? That means that analysis of the data is needed, right? After receiving the data, after returning the data. And then at the very end, policymaker can also ask a one-page recommendation letter, for example, on the irrigation strategies. Yeah? So this is one of the use cases. Can you, next slide, please? Okay. And then the other use case is for the journalists. So journalists can ask, I heard about the flooding in Germany last week. Can you show me the most recent Copernicus Sentinel images of the affected area? Again, this is a problem of text-to-image retrieval because there is this massive archive, and the journalists would like to pick some images related to the flooding event in Germany, for example. Then the agent will return these images. Then also journalists can ask, can you please identify the affected areas? Like in this image on the right, for example, you see. Yeah, so we have identified these 2 cases where an agentic AI can help, considering all our developments on text-to-image or image retrieval problems in general for Sentinel archives. Next slide, please. So in Agent Bigard, we are targeting only image retrieval problems, but the problems are much bigger than just one task. So in our new project, coordinated by Technical University of Athens, we are targeting to develop a Copernicus agent for the next generation environmental intelligence. So here the aim is to optimize the environmental intelligence using different AI models across all the value chains. Okay, so we will be considering several different value chains here. And to do that, we will be developing that agent that will orchestrate different AI models, different data sets, different workflows in a continuous loop on reasoning, execution, interaction, and reflection. Okay. So that is a project that will be officially starting next September. However, we have already started to think on it, started to work on it. And in this project, the agent will be integrated with so many foundation models that we will be developing in that project. And I think that's a very ambitious project. And as a first time in remote sensing community, we are also planning to here develop time series language foundation model. So for example, BigardNet text is image language. There is no time series content in the background, but imagine like image time series language foundation model, which can be relevant for downstream tasks that require temporal data. And then there will be several different agents developed, And that's why we will be also working on multi-agent orchestration here. And the consortium includes research institutions in addition to several SMEs, and we have also SATSEN on board here. We hope to tell you more about it right after it starts, I think. Yes. Next slide, please. So there is no doubt that agentic AI for Earth observation is in the agenda of research and development processes, steps in remote sensing, and we will hear more developments in that direction within this year, definitely. And in that perspective, it is very important to invest time and effort on this. And we see different issues like multi-agent collaboration for Earth observation, geospatial agent-grounded reasoning, or integration with geospatial foundation models, or agent protocols for ground space coordination. So at the moment, we are mainly targeting agents for the ground segment. But we think that it is also highly important that agents are operational on space segment too. Imagine like satellites are collaborating via agents. Or imagine like agents on board, okay, in short. Both for the satellites communication and with communication with the ground station too. So all these topics are also in the agenda of European Space Agency. That's why my institute, Bifold, as my institute, we team up with ESA, PhilLab, and we will be organizing a workshop on all these topics next October in Berlin. So you are all invited. The target audience doesn't include, not only includes researcher scientists, but also developers and policymakers, and students, so on and so forth. So we will be having speakers, having expertise on AI for Earth observation and beyond, because we would like to learn how to design, develop an agent by taking advantage of all the developments from other research communities too. So next slide. Okay, with that, I would like to end my talk. So thank you very much. If you would like to have more information about our group, our developments, datasets, papers, software, please feel free to visit our group website. And if you have any questions to me, I will be also happy to have discussions in the coffee break. Thank you.
So thank you. Thank you, Professor Demir. So do you have any questions before we go to the panel? Direct questions to the keynote. Please.
I just worry how many of us here will be jobless after this agent study. Thank you, yes. I worry, like, if your agents get a very good accuracy, I feel like many people here. I worry about many people here. Sorry, Tom Hengel from Open Job Foundation. I worry about how many people here, companies here, organizations here, will be without job if this agent reach some level of accuracy, which is beyond what we can do ourselves.
So my very honest opinion on it, no one. Because we need agents and human collaboration. That means that we will, agent era in remote sensing just started, and most probably the perfect agents will not come in this year directly, but in few years, like when the Proteus ended, for example, maybe we will have a perfect agent, we will see. But whenever they are there, there will be always need that we collaborate with those agents. So it will be like working together. So this, I believe that they will help us to speed up. So there will be more discoveries coming because they will help us to speed up. Like, for example, some agents are very powerful nowadays for software development, right? So I was discussing with some developers in the companies how they feel about it. And the feedback was like, they help to speed up. So previously, for example, one colleague said, previously maybe he was spending 10 days to write blah, blah code, now it is a single day. So there will be more developments, more quick developments as a result of collaboration with them. So no worries.
That's the stuff we have to discuss here. Thank you. Carlo Buontempo from ECMWF, Copernicus Climate Change Service. Thank you for your talk. Very, very, very interesting. And in a sense, in the discussion we had over yesterday and today, I see there are two main areas. One is about images processing or satellite information processing, and the other one is about predictions, and they are in almost two different camps. Today you presented a lot of the result of the agentic AI and how it works for satellite information, satellite data. How do you see this being applicable, if at all, also to the predictability problem, if you want, to make predictions? So the talk we had yesterday about the AIFS or the AI predictions. Thank you.
So I am not sure if I understand the question. So it's like if these models can be helpful for the predictions.
Yes, if you want.
So from my perspective, these models are designed for predictions. So you have this trained model, and then for your downstream tasks, you are using these models to predict something depending on your problem. Like, for example, land-use land cover classification or so on. So to me, it's very straightforward that they are used for prediction. Am I missing something in the question?
Or maybe we can possibly discuss offline, but in a sense for me, I'm thinking about prediction in time. So like, what is the state of the atmosphere in a week from now, right? Or what is the state of the ocean tomorrow? I mean, we had the presentation from Mercator and presentation from ECMWF, and that's a different
forecasting,
problem.
Basically.
Exactly, indeed.
Okay, so so my expertise is on mainly on the remote sensing data part for Earth observation. So we are lacking the foundation models on the time series content. So we definitely need reliable, large-scale time series foundation models together with their textual descriptions, for example. That's why the current models are not very successful for the time series prediction tasks, let's say, for forecasting or so on. There, we need more models. And that is one of the tasks that we will be considering in this new project Proteus also. But I know that there are different research groups in Europe working in that direction, like for the time series foundation models.
Maybe we can continue this discussion during the panel, because we have other panelists that I'm sure will want to say something about it.
Sorry, the small person here. Firstly, thank you so much for the presentation and intervention. I think that was a perfect kind of foundation for how then we go to, I mean, almost commercialize it. And by that, I mean, what's the work done or the gap then between going from the analytical part to actually, well, what does it mean for other industries as well? So really kind of taking the data, taking that analytical part in the model and the output of the model you created, and then saying, well, here's what it means from a financial lens for, say, the insurance industry. That's kind of more of the go-to-market from the work that you've done so far.
Okay. Again, that's a very general question, but when we create this image text data set for Sentinel data, I started to see much more clearly the differences with respect to core AI machine learning communities. In a conference that I joined a couple of months ago, there was a discussion there in an AI conference, like the models, they reach to a point that they don't know how to make it better, because they use all the internet data for training already, and they are lacking new data. So then they were discussing like we should have synthetic data more. Otherwise, we don't know how to make these models better. Like the GPT versions, last versions, the improvement is very small. But that is not true for our case. According to my knowledge, there is no model that is trained by using all the Copernicus data, for example. And in our case, it is also very challenging to generate textual content. We have images available in the data archives, but we don't have really too much text data that we can associate it with it. That's why as researchers, we are trying to be very creative to create this text data through the additional sources. That's why there are so many things to do there if we would like to have a assistant that is operational at global scale, okay? But then the existing LLMs can help us to process different steps also on from the linguistic point of view. But to analyze the data, we need more. Yeah, so is that answering your question?
Yeah, that's perfect. And I guess maybe the next step, and sorry, I know the panel's coming on, would be maybe more interface with industry to understand.
Definitely.
Yeah,
yes.
Okay, perfect. Thank you so much.
Thank you very much.
Thank you very much, Professor Demir.
Thank you.
And, I'm handing over back to Massimo for the presentation of the panel.
Okay, thank you. See, I think on Slido I've seen one or two questions. There's one about Project Proteus, but we will hold that because in the panel we have also the coordinator of the Project Proteus. Okay. And I invite you to stay with us. And you will forgive me if I must give a, let's say, boring disclaimer that the Project Proteus is good. Let's say the grant is still being prepared, has not been signed, so I have to say this officially has not been signed yet, but we are all looking forward, of course.
I think we will sign it, right?
I'm sorry, I have to say this. So, okay. Thank you. Please have a seat. And this was a very interesting discussion, and I'm sure we'll continue with all our other panelists. I'm going, I can use this one probably, yeah. Okay, now we have 6 distinguished panelists. They all participate in several Horizon Europe projects, and as Marco was explaining, not only managed by us at HaDEA, but also projects managed by REA, by CNECT, by EUSPA. And I'm going to invite them now on stage in no particular order, just as I have my notes, and I will introduce them. So the first one is François de Vieilleville. François is defended his PhD in image processing in 2007 at l'Abri, Université Bordeaux, followed by 4 years of postdoctoral studies where he focused on GPU programming and inverse problems. He joined the private sector in 2011 in remote sensing, where he applied his knowledge on many research studies sponsored by CNES. He embarked on the deep learning train in 2016 and joined Agenium Space in 2018 to push this new paradigm for remote sensing problems and bringing it on board of the satellite. Being the CTO since 2022, he drives the company towards pushing AI on board to bring new capabilities for new space satellites. So François, please join us on stage. Indeed, François will give us a very interesting angle, which is the onboard processing. The next one actually was the gentleman who asked the question before, so the discussion can continue, is Tomislav Engel. Tom is co-founder, director of the Open Job Foundation, co-founder of Environmentics Limited, and project coordinator of Open Earth Monitor, which is an Horizon project, where he advanced open geospatial science and environmental data innovation. His work focuses on integrating machine learning, geostatistics, and Earth observation data to produce high-resolution environmental and soil information at global scales. He is widely recognized for developing open data infrastructures and analytical frameworks that support reproducible environmental modeling. His work highlights how open science and AI-driven geospatial analytics can accelerate environmental monitoring and decision-making. Welcome, Tom, and indeed we will have a very interesting angle from the perspective of the open science and also open source. Then we have Anna Oliveira, is there, yes. Anna is the CTO of Plus Atlantic Collab and an expert in Earth observation application, focusing on machine learning solutions for climate risk mapping and impact assessment. She holds a PhD from the MIT Portugal program, is working on several international projects, including ESA projects, Copernicus C3S and CAMS projects, Destination Earth, and Horizon Europe. Welcome, Anna. Then we have the coordinator, indeed, of Proteus, which is Ioannis Papoutsis, over there. So Ioannis is an assistant professor of remote sensing and artificial intelligence at the National Technical University of Athens and adjunct researcher at the National Observatory of Athens and Athena Research Center. He leads the Orion Lab, focusing on foundation models and machine learning for Earth observation with application in natural hazards and climate change. His research advances self-supervised multimodal and visual language models for spatiotemporal Earth system analysis. He coordinates several EU-funded projects on AI for Earth observation. He's a member of the Alice Society. Welcome, Ioannis. And to end with, we have Jan Guichot of EODYNE. He's the president and founder of EODYNE, which is an SME specialized in operational oceanography. He's an expert in marine monitoring, and in particular, he has invented a system to monitor marine currents, sea currents, in fact, using AIS data from vessels, which is, he will tell us something more about. So welcome to Jan as well. So welcome all of you. We will have a few questions, but I would really ask if you have also questions from the audience to not, let's say, not be afraid to interact, and also if you want to ask questions to each other, feel free to do that so that it's not just a boring one-by-one question. Now, to start with, I will ask each of you a question that is more about the work you're doing, so that will give you also an opportunity to focus more on, let's say, to introduce yourself a bit more in detail. And in fact, I want to start with Ioannis, because you are, so you have been working on AI and big data for Earth observation for many years now. In fact, if I'm not mistaken, we met for the first time for the project eOpen, which was in the fall 2017, so it's almost 10 years that I see you working on this. You have participated in several projects. And so how was this journey for you? So what has changed in these last 10 years, and what are the challenges that you see in turning all this research, all these results into operational, in fact, services?
Okay, thank you. Thank you, Massimo, and thank you very much for the invitation, for the organization of the event. Indeed, it has been a lot of years, almost a decade, as you said. Back in 2017, the challenge was quite fundamental, how to handle the scale of big Copernicus data. And then we had to focus a little bit on developing the infrastructure, the tools to help us access, manage, and analyze very big Copernicus data sets. Then we moved to another project that was called DeepQ, ended a couple of years ago, and the focus shifted from managing data to extracting knowledge using AI. And in that project, I think we produced some very cool prototype applications, leveraging AI on Copernicus and also on non-Earth observation data. For example, assessing the impact of tourism in natural ecosystems and the environment, causally linking climate change with migration patterns in Africa, or even detecting road failures in the Italian Strada using SAR imagery. Now in an ongoing project that is funded by EUSPA, that is called Thinking Earth, we went a step further and said instead of developing a new model every time that we need a new application, let's create what we call a Copernicus Foundation model by jointly modeling Sentinel-1, Sentinel-2, Sentinel-3, Sentinel-5 atmospheric data for the first time in their native resolutions. And the idea is very simple, is to create one common model backbone that can support many different downstream applications without having every time to go to recreate training data sets, annotation pipelines, training from scratch, and committing all these resources that are both costly and it also takes a lot of time. Now, it was also mentioned by Professor Demir, we have Project Proteus that is also very ambitious. And the idea here is to kind of try to transform the services that are delivered by Copernicus core services, so that we exploit really the progress that has been done in AI. And as Beku mentioned, one key component, one key output is what we call Copernicus agents, which we can think about as your personal assistants that have a PhD in remote sensing, a PhD in AI, and understand what Copernicus is about. So it's really very, very ambitious. And this will be done by Begum, hopefully, in this project. So what has changed? A lot has changed throughout this AI boom. What I would say that I see a very key difference is that Earth observation has really entered this AI arena at a global scale, and have appearance in very prestigious conferences like CVPR, NeurIPS, ECCV, ICCV, and back in 2020 this was not the case. We only had like a couple or a handful of papers being present there. Now Earth observation has found its distinct place in these prestigious, let's say, events, and this really accelerates progress. And as a final note on transferring prototype research as, let's say, applications to operational services, okay, co-design and co-development is indeed the way to go, and this is widely known. I would just add that it's not just about bringing users into the equation and bringing them on board, but you also need to bring the right people from the user organizations, the people that have the mandate to adopt technologies at an institutional level. This is my take on that.
Okay, thank you, Jan. I think this has not reassured Tom about losing his job because of AI agents, but I don't know if you want to come back on that.
Yeah, I don't worry only about my job. I worry about the transformation of society, and I worry about the speed everything's happening now. It's quite scary, and I think you see this conference, you just put AI in title and people realize I should go there. But I think the scale of development is really scary. And I was just watching a YouTube Neil deGrasse Tyson on the AI technology with Jeffrey Hinton. He won the Nobel Prize for physics, right? And so you thought that, and I look back, 5 years ago, I thought, if you have a computational problems, you increase your computing capacity, you solve things. And I thought like simple things are computational problems. But what we see now that this AI technology, the biggest developers, they create technology that is possible to reason. And that's something I couldn't predict 5 years ago. I couldn't predict we'll have these, neural nets that are trained in such a way that they can reason, they can check things, and they can see this is wrong. And that's a really scary thing, because we are really close. A couple of years, we are close to having a technology which is smarter than us that can reason. Not just computational problems, but it can reason. It can derive new things, it can create new things, it can create art. It will be able to create music. And so it is really scary, actually. And what if it's used for military purposes? So I think we need to put way more energy. And I look at my children now also, they see this AI, something's happening. Then they read the report that AI technology is degrading cognitive capabilities of people. People are starting to just blindly use it. Nobody does homeworks. Within 2 years now, people don't do homeworks in schools. The kids, they just generate 100% their seminar. They just type in something. They said the only skill you need today is the prompt engineering. And it's really scary. The LinkedIn discussion, what do we do with science now where people publish papers and now people generate whole paper, just prompt engineering, even plots and stuff. And so my colleague Wolfgang Wagner, and he's a professor at the Technical University of Vienna, he said, tell me please, on LinkedIn says, which is the tool I can use to detect this, AI generated. And if you follow it, 2 years ago you had the tools to do it. Today, you cannot detect it anymore. It's gone. So we cannot tell anymore what's human generated, what's computer generated. And so what do? We need to make decisions quickly. It's so many questions popping up. You know, it is also a question like, how is this society going to transform? What are people going to do? 80% of female, unfortunately, female jobs, they will be first. 80% in 5 years, 7 years, redundant. You don't need them. So yeah, it's happening really fast. So it's pretty scary. I hope I didn't change the tone of the...
I don't think you reassured many people in the audience, but but okay, maybe just since you have the microphone, you have a very particular, let's say, perspective because you work very much into open source,
yes,
open science.
Yes.
You know, what is the importance like of fair data, exchange of knowledge, also in this context of?
I think open source is it is becoming. I see it. It is a kind of lighthouse, or you could say it's a right moment for everybody to think about it, because open source means higher transparency, reproducibility, traceability, less bureaucracy. You know, in open source you can connect quicker. Open source is also, many people think open source is about, you know, software or something, but no, actually the key thing of open source is the communities. It's the same as Wikipedians, you know, it's relatively easy to, you know, have a infrastructure backend for Wikipedia. But what's difficult to have 10,000 Wikipedians that know how to do work, and they increase the quality. So it's the Wikipedians of Wikipedia. And the same thing in open source, it's the communities. So it is the social element. So I think it could help, you know, open source, and I think it is important.
Okay, thank you. In this context, when talking about open source, we are talking also about open source intelligence, information that is available. And this is going to be also, let's say, very useful, unfortunately, for the new geopolitical context that we have. AI is going to be very prominent also for security research, and also for the dual use implication that the security research have. Now, so I want to ask something to Jan, because you have been working a lot also with, let's say, open data for specific applications. So what are your views on let's say, how is AI supporting our security research also in this context of your...
Thank you, Massimo, for this question, the introduction. I will try to say good things about AI right now. I'm here on behalf of the AI for COPSEC consortium. So this is a European project related to developing AI solutions in the framework of Copernicus services. And just to give you a quick overview of the project, so we are 10 partners in working on this project. The project is led by Simula, which is a Norwegian institute, experts in AI. And EODINE, my company, we are acting as a technical coordinator on the project. And the project is related to maritime surveillance and maritime safety and security. We are focusing on 4 use cases. One is related to search and rescue at sea. The second one is related to oil spill response. The third one is illegal fishing. And the fourth one is irregular migrations. I said that I would say good things about AI, so I will focus on the search and rescue applications. So one goal and one challenge in the project is to deal with data fusion. One core aspect of the work we are performing is to be able to fuse Earth observation data related to ocean monitoring with in-situ information, which can be collected using IoT devices such as drifters at sea. We are also using AIS for automatic identification system, which is a mandatory system deployed on board of ships. And one other original source, I would say, which is used in the project is information from social networks. We are using social network information to provide more insight to operators using several AI tools. One of the characteristics of the tools we are developing is that we are using AIS as an ocean current sensor. I mean that we are transforming any vessel into a current sensor of opportunity just by using machine learning and AIS data. Doing this, we get a very near real-time information, which is very reliable and precise, with high resolution in space and time, which can be considered as a very, very strong information to complement altimetry on other Earth observation sources. So it gives us a capability to get relevant information for search and rescue when you have to look for a man overboard in a given area. So it means also that we get more chance to locate this person at sea and to save his life. So this is where AI can bring good values in terms of applications. Another way we are using AI in the project is also related to the forecasts we are doing. So we saw a presentation from Mercator yesterday, a very good presentation, so I invite you to have a look to their demo in the demo room. They presented GlowNet. So in the project, AI for COPSEC, we are also developing a forecast capability using deep learning. But in a different way, we are using a diffusion model. Diffusion models are known to be models to process, to provide images. So this is DALI or Nano Banana and so on. But they can be used also to provide forecasts on ocean currents. And this is what we do in the project AI for COPSEC. And we are feeding this model, diffusion models, using the IS information, the altimetry measurement from Earth observation satellites, the in-situ information, etc., bringing very, very accurate forecasts to enhance the drift trajectory and the drift forecast for a man overboard. So this is another way we are using the value of AI to be more efficient at sea and bringing better information to operators.
Okay, thank you. And talking about forecast, indeed there was this question of Carl about using AI for predictions. Now we have the chance to have Anna here, who is, you are doing exactly that, right? So you work in the project Terra DT, where you are building a digital twin of the Earth to do exactly that, so to climate modeling and predictions.
Yes.
So can you tell us about it?
So, and I will try to address also your concerns because, by the way, thank you for pointing those out because I think it's beneficial for us also to have the tough conversations in these forums. And I agree with your perspective, even if there are good parts also to be mentioned. And about weather, I think weather and climate in general make a good use case or a good sectoral application, if we can call it a sector, because it's multi-sectoral in the end, but topic to highlight this. So for decades now, and there are much more experienced people in this room than I am, working on weather and climate, we have been seeing an evolution in weather forecast that is unprecedented, and it's not only about AI and the technology. It's grounded a lot in the heritage of observations that we do have. And AI, despite being quite sexy, without any kind of heritage, then the tool by itself does nothing to offer. And if we don't constantly update these AIs with more information, more observations, more direct observations, to train the models, to adjust the models, to assimilate these into forecasts, then things will cease to improve in the end, and there's no novelty to come in the future. So in the end, and addressing your concerns, I would say that maybe we are overvaluing and over-supporting AI, and somehow losing a bit of focus on direct observations, which are in the end the power source for these AIs to actually deliver on something. And if this stewardship of the direct observations and the infrastructure that we have in place and the knowledge that we have been gathering for data for decades is the data upon which the AI is building, maybe whoever takes advantage of this AI has to somehow give back to those that are supporting systematically. Because AI is a tool. We can think about, I don't know, those here that have a Thermomix at home. And when Thermomix came up, people were like, oh, they will replace chefs. They didn't. They are a tool. So I also agree with you that AI agents are a tool as long as there is space and money to pay for those making the questions to these agents. And what is concerning is exactly what you said, that people cease to make questions to the agents because they just trust them. without questioning. So as long as there is money and support for people making questions, the agents become a tool and not a replacement for people. And concerning weather, again, and I'm working on urban climate, which it's actually a post-processing exercise, not forecasting per se. We are working on the Teridity consortium, and Yanni is going to present in the next panel, and we are working with ECMWF on the urban heat health forecasting with extremity as well. And both are an exercise of building a post-processing algorithm that takes advantage of citizen-owned stations, quality controlled, of course, because those are not federated, so that we improve the resolution and the precision of these global models, which are indeed unprecedented, but still do not look into the neighborhood level. So in the end, again, the secret sauce is this mixture of the physical models that we have as the background with the in situ observations that we need to, with domain knowledge, quality control, and post-process and assimilate, to then come to an AI result that is of added value. And there's the last step, which is to deliver this back to the society. And to deliver back to the society, and I'm working with urban planners, medical doctors, they don't actually are interested in the pretty pictures by themselves. They want to know what to do with that. And it's much more efficient if I go to the medical doctors with a simpler map saying, tomorrow you will have 20% excess hospital admissions in this and this and this municipality because of a heat wave. It's much more efficient because they can act upon it. And again, jobs, these are medical doctors that need to be there to support the public health system. So I think there's still a role for the human to be in the loop, and the women, if we can so, preferably. And I think there is a good part. The only thing that concerns me, and with this I agree with you, is whether the resources, especially, let's say, the geopoliticals, the money, the financial markets, become tied to the AI, those that have the AI, instead of, let's say, splitting the returns of that investment across those that in the end are feeding their intellectual property into these AIs to be learning. And this is it.
Okay, thank you. Maybe before going to Philippe, you made me think when you were talking about the fact that the models need to be updated and so on. It made me think of a discussion I had yesterday with Begun, where we were talking about embeddings, because it was this very interesting presentation about embeddings, and then you told me you are not a big fan of embeddings. Would you mind to elaborate on that?
Yes. So yesterday there were some phrases like it's the biggest, it's one of the biggest inventions in Earth observation to have embeddings also. There were this kind of phrases yesterday I was hearing, which I do not agree at all. Maybe I can very shortly explain why. So since machine learning and pattern recognition exist, representing an image with a feature vector exists. So if the embeddings are the descriptors of images, right? So it's nothing that is new, to be honest. So I don't see it as an invention at all. But compared to maybe 30 years ago, 20 years ago, now we have different models to describe the complex content of remote sensing data, and it is evolving fast also. There are several different models coming every day almost, and so we have different models to obtain embeddings. But as a term, so it means representing an image with a feature which was always existing, so I don't see that as an invention. However, maybe can I finish, because I know that is a debate now. So in 2013, for example, I was working for a project funded by European Space Agency. There we were developing a search engine. And that time I was a postdoctoral researcher, and it was my task to develop the feature extractors for images. And that time, suggested by the European Space Agency, we call the database where we store the features, it's the auxiliary database. So we were saying archive or database where we put the images, and auxiliary archive where we put the descriptors. So what is a descriptor? It is exactly what you call as embedding now. But the methodologies used completely change. So now our models are much more capable of characterizing complex spatial, spectral, temporal content of the data. So the embeddings are much more powerful. And thanks to all the availabilities of infrastructures and so on and so forth, now we can process the global scale data. So it is, what is invention? Maybe it is this engineering part. Okay, so to make the thing scalable, to obtain the embeddings at global scale data. But then if you are defending that embeddings can be replaced with images, I am so sorry to tell it, but this will never happen because we need images to process, because we are always developing the models. It's not like you develop one model, you obtain the embedding, and it's done. It's not done. As researchers, we always go forward. We always make the things better and better. So we need the images so that we can produce new embeddings. So if you will be just providing us embeddings, this will be the end of the things. So this will not be the solution from my perspective. But it is true that if you have embeddings, you can store them and you can use them definitely for image search and retrieval. This is how the search engines work. That's why it is not a new funding. So it was known, I don't know for how many years. All the search engines are based on index data. So like Google Image works in that way. So you have the image features indexed in a hash table, and then whenever you have the search by image problem, from the hash table they were taken. So it's not like it's not like they are useless, but what I am saying that I don't see any way that they can replace the images. Because if you have the embeddings, maybe last comment, if you have the embeddings, then what will happen if there's a new model coming? You need to create new embeddings. Okay, that's why we always need as the starting point images. This is what I want to say. Thank you.
So that's something to say about that.
Maybe I want to respond from a bit different perspective. And for me, it was last year in Living Planet Symposium. I came to see the talk by the DeepMind group that made the Alpha Earth, and they just put them online maybe a few weeks before that. And you know, we have a lot of point data, we have a lot of projects, we have a large also point data sets, and we process the ISAT, for example, points, it's like 200 billion points or something. And we were looking, wow, okay, these guys, DeepMind, I mean, they're very progressive, so let's see. And we overlay the points and we fit the models, and we get about the same accuracy as we got in a project that took us maybe 2 years, you know, to prepare things, because it is a revolution. You know, I agree with you, it's embeddings are kind of next generation principal components, and in essence it's, you know, it's all known basically. But still, how they managed to remove the clouds and make everything 10 meter and compress. You have, for example, for 1 pixel, you know, anywhere in the world, if you take a 1 year of Earth observation data, you have maybe, you know, a few thousand images when you take all the Landsat and Sentinel and I don't know, Sentinel-1, Sentinel-2. So you have a few thousand, maybe 2,000 images, and you come to 64 embeddings. And they look like they contain most of the information, so it's an incredible compression. And then they make it available as cloud optimized, you know, data, so you can do in parallel overlay, and you fit the model and you make a data which is about the same accuracy as we got with using, like, really processing everything manually. So it is a revolution, I mean, there's no doubt. And you know, let me put it this way, it speeds you up about 100 times. That's my estimate. It speeds you up because if you don't have the embeddings, you know, what you have to get rid of the clouds, you have to aggregate, you have to do pre-processing, you know, it's a lot of computing. And then what is also silly, that all these groups, you know, there's so many groups today working on Earth observation data, all of them, they have to do this pre-processing. All of them, they have to do the same thing. With embeddings, it's done, just go ahead and do application. And computers don't care about the bands or like how things look like, you know. For computers, that doesn't matter. The only thing that matters is the accuracy. If you extract a signal, so this embedding is a signal, so you do decomposition of the signal. And if this decomposition doesn't lose much of information, then you can combine it further with machine learning and with LLMs, and you save a lot of space, you save computing time, you save all the pre-processing. It's really a revolution, you know, it's without doubt. And I agree with you, this Alpha Earth model, you know, they are very competitive, Silicon Valley people, whatever. So they did it. I don't know if they even have a peer review publication also. Also very shocking today, this Silicon Valley, big tech, you know, they can make something. There's no publication, there's no peer review, you know, poof, we made it. A bit arrogant, I could say. But then, for example, Tessera, Cambridge, it's open source. There is a publication, they show it's even better accuracy. And Tessera is really, I think, good project. And they have problem computing whole world. They don't have the resources. But let's say if we had Tessera for all the people, I'm telling you, you have about 100 times more capacity to do work because it's ready to go. You know, these embeddings are ready to go. I'm not talking about the models. I'm not talking about training data, but somebody really makes these embeddings and maintains them. Every year adds the new embedding, right? And improves and answers questions. It's a revolution. It's a revolution to applications, you know.
No, thank you, because you gave me the perfect, let's say, bridge to ask Francois some questions, but I don't know if you had something to come back.
Discuss afterwards.
Okay, we can, because Francois, you're working on a very, very special application, so you work in the project Age Space, you are specialized in age processing. When by age we mean really up there in the sky on board of the satellite, where you have some very specific constraints. So these gains in efficiency, both for the processing on board and for the transmission of data, are very relevant for what you do. Can you tell us a bit more what you do? And I've seen that you were nodding heavily, so maybe.
Yeah, so thank you so much for giving me the opportunity to talk about this part of AI, which is not often so mentioned, because most of AI is done on ground, as you know, and we have lots of talk about the big models, all the issue that we have with these big models, the consumption in terms of electric power, in terms of resources. But I will start first with a very simple story. In Sentinel-2 data, basically, the satellites take pictures, okay? It's the old-fashioned way, that is to say we take measurements. Then we download these measurements on ground and we transform it back to actual physical values, okay? What happens is that Sentinel-2 pixels, half of them are clouds. Half of your bandwidth is used by cloud. If I'm being very sarcastic, I would say something like the Sentinel-2 cost basically 351 millions. We have paid 150 millions for clouds. That's the old-fashioned. Now, what can AI bring to us? If you put the models on board, then you can start making data selection on board, which means, in the case of Sentinel-2, we would just discard the clouds. So we save bandwidth, first. Second, you don't have to download as much data. Great. So you can take more data. If you compress even more, like if you are using a use case for plastics or even boats, the data selection compression rate is far more than 1/100, which means that if you have enough computing power, you can scan all along the trace of the satellites. It's not like you are taking 100 pictures a day. You just scan the whole trace of the satellite for 12 hours, because, of course, in those observations, we still need light. But this is, in my opinion, a big change of paradigm, because it allows us to make new use cases, because we increase the capacities of the satellites. And of course, this is no easy task, because when you are on a satellite, you don't have a GPU with 250 GDP. It's not possible to do that. So usually you are between 2 and 10 watts. So of course, the compute is reduced by the same factor. So you have to make smaller model. You have to adapt them. And this is one of our specialties, the compression. It is known by Hinton also, which was the distillation stuff. And the thing is, once you have done that, you're really happy. But it's still not enough, because the hardware that we use on the satellites is very different. I'm talking about the hardware we use for heritage, like the SOC FPGA part. And for these, you need very specific middleware to be able to translate it. And in the HSpice project, we're really lucky to have an extremely great partner with CERN, because they have made a software, HLS4ML, which basically is on Xilinx hardware, which is one of the very big reference in SOC FPGA. The software, which is made by Europe, is 6 times more efficient than the native solution from Xilinx, even though it's their hardware. Nobody can do better than them. They know their hardware, but still, it is manageable. And this needs to be extended to European hardware, because this will allow more sovereignty for us. And then, with this software, with smaller model, sovereign hardware, we can go and build more use cases. And these two stacks, the hardware stack, but also the middleware one, they have to be secure at European level so that we get the cost down, which means we may have the opportunity to build use cases that meet the offer and the demand, so that at some point we can build new use cases for both SME, big companies, and Europe.
Okay, no, thank you, because you bring on the table something that is it's not been discussed very much in this community, early because we are focusing on algorithms, on software, but the part of the hardware is very important, especially from the EU perspective, the EU space. So we are investing money in developing European hardware for the reasons you were explaining, so the non-dependence, so you don't want to be dependent from foreign technology. And what you're doing indeed, having, let's say, working on having your, basically your models work on European FPGA, those non-explore more specifically, it's very important work. For those who don't know, non-explore is an FPGA that has been developed thanks also to European funding and projects that we are proud, as HaDEA, we are proud to fund. Now, we have had a first round of questions. Maybe before going to continuing, I want to ask if anyone wants already to ask something to the speakers, or maybe if we have something online. Anyone in the room? Yes.
Yes, thanks. Mark Dowell from the European Commission's Joint Research Centre. I think, Carlo before made a point, I think, after the keynote speech on these two kind of domain or application areas we've addressed a lot in the last couple of days on more the forecasting side and then the kind of image analysis and interpretation. I think one thing that I'm missing a bit, at least kind of in the Copernicus context, is the use of, and I'm particularly like this discussion on agents, the use of these type of agents with respect to Copernicus service output. So maybe that is kind of intended to be included in the image part, but you seem to be focusing a lot on the image analysis and things like this and not so much in that. And I'm particularly interested with the direction that Proteus will go as a project. And in my mind, one thing that is missing a bit is really dedicated agents to make better use of Copernicus service output. One thing I had in mind when I was listening to you was you may be aware that in Copernicus we have this concept of thematic hubs that we have a couple already active run by Mercator and ECMWF and a couple more that are being developed at the moment. But I could imagine at some point we could almost have a thematic hub on demand that basically a user defines a specific theme and a specific area he's interested in, and we bring in all of the relevant Copernicus products from the different services to address that specific application area, maybe with specific questions and things like this. So is there some view, and maybe it's a specific question to the colleagues on the panel who will be involved in Proteus, to really think about how we make best use of the cumulative output from all of the services? Thank you.
Maybe Anis, you want to take that?
Okay, so thank you for the question. I will answer with some reservation because we have to do some analysis first. Indeed, the primary focus is on image data and also on forecasting. This is very clear, at least in the proposal, because this is not a project that is being implemented. It will start from September onwards. Having said that, indeed, how we have structured at least the use cases is to be not thematically focused, but being able to borrow stuff and products from different Copernicus services. So from GMES, for example, from C3S, and getting different components, different products, different services, and combining them to solve a user problem. Being able to translate all services, so going from image data to high-level products, I think it's a different beast, but I think for sure we would like to play a little bit with that. Yes? I don't know, Begum, if you agree on that.
Okay, so that answers at least partly, but I'm sure there will be, we'll continue discussing this also throughout the implementation of the project. There will be workshops. I mean, you will keep us updated on how the project is progressing, so I'm sure about that. Now, I think there are still in the room somebody else? Oh, no, okay, online, but you need a microphone.
Yeah, thank you. I would like to come in for the online participants. I would like to raise two interesting questions we got. First is again on the Proteus project, Ioannis mainly, and the question is there also a link to destination and related foundation model developments planned, or will this purely be happened in the general Copernicus realms?
Okay, so the question is about foundation model development within Proteus. So we have indeed a very distinct activity for this, for developing foundation models. As Begum mentioned, the temporal aspect is also very important, so developing foundation models that can accommodate the temporal sequences that are inherent in Earth observation, also the multimodality, and also linking this with physical-based consistency of foundation models. So all these things, including also uncertainty estimation from foundation models, are going to be key pillars for model development.
Okay, and you said you had another one?
Yeah, I have a second question to begin, starting with your keynote presentation, and coming back a bit to what Mark said about the agents. The question is, will the agents be able to identify if a query cannot be addressed with Sentinel data? For example, if the resolution is not good enough, say to detect, for example, single tree illegal logging, or will the agents always provide a result? So it's quite on the accuracy in the future. I find a good question.
Okay, so so with the agent figured, with the agent figured, we are directly targeting Sentinel-2, Sentinel-1 data. So the search and retrieval problems will be related to the task that their resolution can support, to be honest. And for the Proteus, I think we have different types of data, and very high resolution is included, right? So there we can have a more precise analysis, and this can be answered. I think such questions will be answered with this agent. Is there any part of the question that I missed to answer?
Okay, I will go on with this forever, but we have only 3 minutes left. So unless there are, there's another question there.
Yes, hello. My question would be, all the discussion here seems to be kind of framed in an LLM paradigm. Do you have anything to say about alternatives like world model, new developments, and so on, that would go in a different direction, that maybe could be more interesting for Earth observation, or am I wrong?
I can answer very quickly. First of all, I think we had different types of questions, not based on LLM only. But yes, maybe the agent keyword was very attractive and it gave you an impression about LLM side only. But it is not. So the agents that we are talking here, they are LLM agents targeting visual language tasks. So, and for example, in the Proteus, we will have several different foundation models integrated within the agent. So I think a foundation model can be image-based model or multimodal, including text and so on, right? So with the world model, I think you are referring to a foundation model, am I right? So, I mean, this world model is the term that is frequently used in robotic field, I think, but for us, for Earth observation, I would call it as a foundation model trained on very large scale data. Are we on the same page? Yes, so then I do not agree that we are just talking about LLMs, and definitely foundation models are very important in remote sensing to support several different tasks. They are all relevant.
Within our project, what pops up as the hottest topic probably is this merging of the machine learning and process-based models and so-called hybrid process-based models, or they call it also knowledge-guided machine learning, and especially on space-time data. So this, you don't need a foundation model for that, but that's a very interesting, and we have some solutions. We develop libraries. There's Max Planck has a library in Julia, actually, programming language. So for the hybrid process-based machine learning model, it's a really hot topic. So I don't know if that's what you meant. And then the other very interesting thing is so as we are getting more and more time series data, time series images, it's very interesting to be able to detect disturbances, you know, like forest tree species disturbances due to drought or some pest, ecosystem, soil health disturbances. That's also a very interesting area. It is kind of recognizing signal. It's something like we're trying to get is knowledge of you know, epidemiology or health research. We now try to get it also to environmental sciences, ecosystem material. Also a very hot topic in the work we do.
Okay.
So
another question.
And there was just to mention one more thing was a lot of work has been. We had a conference last year in Perugia, and a lot of work is like we're purely on these biophysical indices. And you know, we look at plants like a FAPAR or NDVI, and we look at soil moisture, I don't know. And so it's a very like this biophysical. And then this group went and says, well, can we correlate something from social sciences, going even to well-being, to happiness, you know, health of people? Can you model that also together with environmental dynamics and, you know, climate change and things? So you have this both social variables, or anthropological variables, and environmental variables. So it's a really hot topic, and it's a very interesting, and they are getting some results. Of course, when you just think about it, you know, it's your quality of life, your quality of individual life, but also if you look at Eurostat data and things, you can find correlation. You know, it does reflect it, where you have more problems with the air quality, industry, commuting, I don't know, where you have in future, you'll have a problem with the impact of climate change. You know, it will affect also our well-being. So it's a very also hot topic. So these are just some topics. Okay. So it's just to say that it's not all about just LLMs and running big models.
Okay, very good. So we ran out of time. So, but if you are willing to give up your chocolate, we still have one question and then 30 seconds each to close. So one or two questions in the back, but quickly, please.
Okay, yeah, a quick question. Thanks again, Begun, also for the very nice presentation. And I was wondering about key challenges, to pick your brain, for academic sector and students, about how to direct efforts to adapt and train the right people and find the right people. Do you have any key comments or thoughts on the latest evolutions, like how courses can be adjusted or focus can be directed? Thanks.
Thank you very much. This is a very good question. So it is, of course, our challenge. Thank you. Yeah, this is a very good question. Thank you very much. So I'm teaching to computer engineering and computer science students, and also our students are very much worried, thinking that maybe the existing tools will be doing junior engineering tasks already, and they may have challenges in finding jobs. And we train them in a way that they should they should definitely learn the basics. So how to design, develop, basics on data management, basics on machine learning, and in my course, through my courses, they learn basics on remote sensing, challenges on the different types of remote sensing data and so on, because we motivate them that they are the ones who can develop the next generation of these tools. And plus, we think that in the near future, the engineers who can efficiently, effectively work with these tools will have good opportunities. So we don't tell them don't learn, don't trust, so on. Use them, learn how to use them, but always check, don't trust completely. So we are trying to teach them how to responsibly use these tools, but also showing the importance of foundations, fundamentals of every discipline.
Okay. Thank you. And
just if I may reflect that we had a summer school last autumn, 120 people, summer school Earth Observation Data Science, and the CEO of NVIDIA, I mean, it's a great company. It's the company is more valuable than some European countries. But he said, you don't have to learn any more computer languages. The only language you have to know now is English. And so you should the only skill you should have is a prompt engineering. I'm so much opposite to that. Don't believe that. Don't believe lots of things from Silicon Valley today. And you actually now I think that these things are going so fast, and we have to check all these things. So many people say, oh, AI, great, so I do less work. I don't feel that. I feel like I'm doing more work, actually. And I feel like that I have to know the computer science and computer languages even more.
You have to know what it takes you
because
longer.
somebody has to check all that. Because as soon as once you pass that point that you blindly believe, it becomes like a religion. And it's a very scary thing, you know.
You have
so
to
actually,
see if it takes you longer to write the prompt and then check the results than write the essay yourself.
But you know, we use it. My colleague Landry was just showing me this Pi agent, like little agent, makes the whole project. Poof, makes the code, runs it, checks it. You can create a Python library today. You know, when I started data science 20 years ago, you know, I would sit like for 3 to 6 months to make a library in R, right? And then I have to document it, blah, blah. Now you write 2 sentences and creates your library, you know? And so it's a really scary, but still you need to check it. So you still have to know and learn computer languages. Tell your kids, you know, use AI, but read what you do and learn things. It's not going to make your life easier. It's going to make your life worse, actually.
Okay. Thank you. Now, I'm sure we can continue the discussion with a coffee break. So now, just to close in one sentence, what do you think should be the priorities of research in this field in the coming 5 years? And I want to start with Anna, maybe just briefly. Yes.
Well, I will probably repeat myself, but I would say that we can be a beacon, especially in a phase in which we are seeing the digital transition and some disinvestment on the other side of the Atlantic in infrastructure. And by infrastructure, I mean direct observations, both in the ocean and land, and atmosphere, of course. So I would say that Europe should not lose its ability to be a beacon of trustworthiness and have some fiducial direct observations. And this includes, of course, human-generated data. No, I'm talking about physics, ocean and atmospheric physics, because it's where I work. But there are other things that we offer our data and that we should be stewards of that. Because in the end, that's where we will find if those agents are performing well or not. So we should all done to that and make sure that it's trustworthy.
Okay, thank you. François, what do you think should be the priorities in the coming years?
In my opinion, we have to stop going to the bigger and bigger models, and we have to start understanding what's really happening. Recent papers, for example, for the transformer part was basically saying it is just neural network are just a dictionary, basically. The answer that you get is just the closest elements of your data set from your input. So you just take the one which are the closer and you build a response with that. It's just a kernel, basically. And the thing is, we have to understand how to make it more efficient so that we can compress more and have smaller models, because we can spend our time making models 5 billion parameter and afterwards having data center that take half square of France or whatever. It doesn't make any sense. We have to stop that madness.
Okay, thank you. And also, Jan, from your perspective?
Thank you. From my perspective, one key topic is related to the data. We need to release the data, not in a general way, but to make it accessible sector by sector. And just to refer to what's happening today, I consider that we lost the LLM war. So today the leaders are in the US. They were able to crowd the internet to build capabilities in the analysis of the text, etc. And this is why they were faster than us, but they are not smarter than us. So they were just able to do it faster. And the next move will be related to the expertise in different fields. And we all own some specific data, some know-how. We need to be shared to enhance AI capabilities. But if we open it in a general way, we may lose again the next war, I would say. So for me, the importance is to release the data in a selective way, not in an open way. So maybe this is something we are not agree. We don't agree, but this is a way to go forward, and it should be a priority for the next years, I guess.
Okay, thank you. Now we are 10 minutes behind schedule, so I really apologize for that, but as I said, I could go on forever. Unless you have any burning final comments.
Very final comment from my side. I think we need to collaborate with companies. So I would like to highlight that researchers can do benchmarking, researchers can realize prototypes, but to make the things operational at large scale, we need the companies as ambitious as us to collaborate and make the things operational at global scale. So please, so this is a message to companies here. Yep. So please don't hesitate to contact university partners, institutions, research institutions, because you can get very cool ideas from them, and we can help you to make the things scalable, efficient, accurate, and functioning. Thank you.
Thank you. And on this note of this plea for cooperation between research and industry, I think is the perfect way to end this. Thank you again to all our panelists. A big round of applause. And I'm sure they will be happy to talk to you during the coffee break if you have more questions for them. Thank you very much.
Okay, please take your seats. Okay, so welcome for the last session of the workshop. I think we have had really 2 very busy days. Let's try to make this last session really count. So there was a lot of information. We could use AI actually to make a synthesis, but we opted for a different approach. The approach we opted for is to have a program in 2 parts, with first a presentation to wrap up things around how digital twin can bring benefit from climate. And then we'll have a panel discussion with a sample of stakeholders from the ecosystem, and we'll discuss some take-home messages and some outlook for the next few years as part of the discussion, and then engaging more widely with you in the room and with people online. So before starting this discussion, let me call Jenny Kontkanen, coming from the CSE IT Center of Science in Finland. She is development manager in digital twin technology, and she will wrap up discussion in a way regarding digital twins for climate. Jenny, the floor is yours.
Okay, great. Thanks so much. And now let's hope that we get the slides there. Okay, we are in the conclusions, so let's hope we get them to the beginning. That would... Okay, that's perfect. And now it will be a mystery if the clicker works, but we'll manage anyway. So hello, everyone. Okay, now it worked, even I didn't mean to change the slide yet. But hello, everyone. I'm Jenny Kontkanen from CSE IT Center for Science. And like said, I will discuss digital twins for climate and also give some examples related to them, how this research and innovation can lead towards operational services. So although we already had a very nice session on digital twins earlier, I will start with brief reasoning that why digital twins are a useful concept in earth sciences. And this is because digital twins of Earth can provide capabilities that traditional models or Earth observation data cannot provide. So this includes provision of consistent information of environmental changes and their impacts at high spatial and temporal resolution, together with enhanced capabilities for interactivity, which can mean, for example, that users can access the results near real time and explore what-if scenarios. So we heard about that earlier today. And finally, these digital twins often combine physics and AI-based models and Earth observation data to produce actionable information. So we all here are probably already familiar with Destination Earth initiative that develops digital twins to support decision-making, for example, related to climate change. And Destination Earth has two high-priority digital twins. There is a climate digital twin and extremes weather digital twin, and I will soon talk a little bit more about the climate digital twin. In addition to Destination Earth initiative, these digital twins and their components are also developed in other EU and nationally funded projects, and I will also give an example related to that. So, okay, now I try to change the slide. Okay, maybe, okay, yes, now it changed. There is just a bit of delay. So, okay. So to conclude, digital twins can transform the provision of climate information due to these novel capabilities. Okay, so what is Destination Earth Climate Digital Twin? So it aims to be an operational climate information system that in a novel way integrates kilometer-scale global climate models with impact sector applications to produce actionable information to support climate adaptation. This is illustrated in this schematic. I'm not sure how well you can see it, but basically on the left-hand side, there are the global kilometer-scale climate models, and the data from these models is streamed to different applications, ranging from monitoring and evaluation applications to impact sector applications. Then overall, this climate DT produces then data to support decision-making, including multi-decadal projections, storylines of future extreme events, as well as user-relevant indicators coming from these impact sector applications. So, yeah, so these kilometer-scale global simulations that are performed as part of the climate DT provide globally consistent information on climate change impacts at high spatial and temporal resolutions. And this is illustrated in this animation, where on the left-hand side you can see simulations from climate DT at 5-kilometer spatial resolution. On the right-hand side you can see simulations from some other state-of-the-art climate modeling activities. And you can really see the great difference in the level of detail achieved in these simulations. Then here is, oops, now I went too fast. So here is another example of the added value of this global kilometer scale climate simulations. So these, if you can see the figures there, they show a precipitation pattern over Tenerife Island. Left-hand side you can see results from Cordex. Then in the blue box you can see climate DT 5-kilometer resolution simulations, and on the right-hand side results from observations. And what we can see here is that these climate DT high-resolution simulations can capture this precipitation pattern over Tenerife Island very nicely. So what is really novel in climate DT is this approach where we integrate the applications for impact sectors and for monitoring and evaluation in the same workflow with climate models. So we use same format and data governance for the 3 global climate models, which means that the applications don't need to know which model output they are processing. Then these impact sector applications produce tailored user-relevant indicators on the fly, so while the climate simulation is running, based on these climate model outputs. Also, these monitoring, evaluation, and bias adjustment applications process the data on the fly. And in addition, there is also a possibility to access the reduced version of this data via DestinE platform for offline processing. So overall, these novel technological solutions that are developed as part of the Destination Earth Climate Digital Twin can benefit also the development of other climate and environmental services. Yes. Okay, so in addition to Destination Earth, there are also research projects that feed into DestinE. And one example of such project is Horizon Europe-funded TerraDT project that develops new components to be integrated as part of the Destination Earth Climate DT. So TerraDT has quite a strong focus on development of AI and machine learning approaches for replacing or improving components of kilometer scale Earth system models, focused especially on sea ice, aerosols, land surface, and ice sheets. So this is now an example of this hybrid approach that was discussed earlier in the digital twin session. In addition, as part of the TerraDT project, AI and machine learning is used for developing impact models that provide user-relevant information by combining Earth observation data and models. And for these, we focus on forests, urban heat extremes, and urban carbon sequestration. And I have here an example from this urban heat extremes case, which is led by CoLab Atlantic, from where Anna, who was in the previous panel, is. And yeah, so their approach is that they developed this machine learning model for urban extremes using observational data from citizen-owned stations and also other sources. Then in the future, they will generate city-scale information on future temperature extremes using these kilometer-scale climate projections from Destination Earth and also from TerraDT project after downscaling these simulations. And as part of the project, we will also develop an interactive user interface that will enable users to explore different options for urban climate adaptation. And this is, in my view, a very nice example of how these kind of research projects are critical for developing the Destination Earth system, as well as other more operational services further, and also keeping them state of the art. Finally, a few words about Euro-HPC AI factories, although these were discussed already quite a lot yesterday. So like we learned yesterday, they are ecosystems formed around supercomputers to foster AI development in Europe, and they are targeted at European startups, SMEs, and researchers. And I believe that these AI factory services can also facilitate using AI for developing also climate and Earth observation services, as they include computing capacity, expert support, and also data sets and related services. So for example, in Lumi AI Factory, we have this concept dataset as a service that provides curated datasets close to HPC resources. Also, upcoming thematic data labs that will be part of AI factories will provide datasets and tools to different communities, including also climate and Earth observation communities. So to conclude, digital twins that combine physics-based models, machine learning approaches, and Earth observation data can transform how the climate information is provided, and innovations from Destination Earth initiative can benefit also the development of other climate and environmental services. Then research projects are crucial for keeping these operational services cutting edge. And finally, these Euro-HPC AI factories can boost the use of AI in climate and Earth observation services. Thank you.
Thank you, Jenny. Thank you very much. So it was good to basically close the loop. We started with Gaspard Demure introducing the AI gigafactories, and we end again with the AI gigafactories. Are there some questions from Jenny before we start with the panel? Oh. Okay, so thank you very much. So let me call on the panel our participants. The first participants, you know him already. It's Babis Tsilakidis from DG CNECT. Babis is the head of sector in charge of Destination Earth. Welcome, Babis. The second panelist will be Elisabeth Amdouche. Elisabeth is Deputy Head of Unit of the Earth Observation Unit, who is in charge of Copernicus. So you see we have the key stakeholders of the workshop. We have also a representative from the commercial sector and industry. It's Aurélien de Truchy, who is Vice President Data Sciences from Kairos. We have an eminent representative of Copernicus Services in the name of Peter Salamon. Peter works at DG JRC and is the head of the Copernicus Emergency Management Service. And last but not least, we have from DG RTD, Franz Himmler. Franz is head of sector on environmental observations. So you see that with this setup, we have an excellent coverage of the ecosystem. We should be able to jog back to many of the things that have been said and answer probably the most important question, which is, so what? So we've seen lots of things, lots of ideas, lots of things. Here the purpose of the session is to go forward, each of us, back home or still in Brussels, to basically have some clear plans on how to enhance AI uptake in Earth observation-based services. So I will start the loop of questions. I will ask actually the first question exactly the same for all the panelists. The first question is to ask about the take-home message, and I will start with Babis. So Babis, what are your key take-home messages from these 2 days?
Many thanks. That's an important question, of course, because we all spent 2 days here, and we need somehow to now summarize. And I think there were many conclusions made already. For me, the way I see it is that, and I will take, I think, a quote from one of the participants, is that to move from AI pilots to AI operations, you need to build trust.
And it's not only about trust. The way I understand it is that common challenges, but also common opportunities that we see when it comes to the usage of AI in all the domains, they also appear here in Earth observation, also in Earth system modeling. So the skills, ethical AI, quality and availability of data, and even resistance to change. There are all elements to be considered. And yes, with AI, we can go faster and better, but still there has to be a value proposition that can ensure the uptake and, of course, the tackling of challenges. For me, these were important conclusions. At some point, I think we may even reach a point where we will question ourselves about what do we mean with operations under AI. You can see outside the AI forecast in a box. It just needs a laptop to run. So this kind of actions and this kind of results, they change the whole landscape. And on the positive side, I think, and that's my last takeaway message, is that yes, we are there. Stay tuned. You have seen that we are preparing this array of AI factories, the gigafactories. So the data spaces, they will all come together. So all the basic ingredients, data, compute power, what we will need to develop further AI is going to be there. So third takeaway is stay tuned, as I say.
Thanks, Babis. My second question is as we are really almost starting the phase 3 of DestinE, so what is there in store in phase 3 of DestinE in terms of progressing with AI? We've seen a number of presentations showing what has been done actually as part of mostly phase 2 of DestinE. So what is in store?
So in phase 3, which will start June this year and will go until June 2028, you can expect, of course, the continuation of all the AI activities. The spearhead activity would be the frontier model of the Earth system, which is also the flagship action under the Apply AI strategy for climate and environment. So this is already in the pipeline with a number of activities such as a climate emulator, or of course a chatbot that we are preparing. Also a lot of work on uncertainty quantification and communication. So we will continue like this. And then, of course, in phase 3, we will also consolidate the system, and we will strengthen all the operational capabilities of Destination Earth. The Extreme Digital Twin is going to run on the HPC of ECMWF, so that will become also operational. So the Climate Digital Twin will also go further with new runs. And then we have also the synergies that we are going now. It's the new journey that we are going to embark with Copernicus and DEFIS, also with a digital twin of the ocean in this context, the same context, with our local digital twins that are being prepared as we speak under the Digital Europe program. So the data spaces, as I said, and for me, perhaps, again, this goes back to my last takeaway, it's the whole effort to make, let's say, this thread, the continuum from Destination Earth to the data labs to the AI factories becoming reality. So it's a thread that runs horizontally in all of these activities. Data spaces, Destination Earth, AI factories, and data labs, all of them together in order to support this ecosystem that is now emerging. So for me, I think these are the main activities for phase 3.
Thank you, Babi. So let me continue this line with the modeling, the satellites, and moving on to Copernicus and Earth observation with Elisabeth. So let's start with the same question as for first question as for Babis. So Elisabeth, what are your key take-home message from this workshop?
I think I can take this one. Yes. So my key takeaway is that it was really worth it. Mitch, you will be able to tell me how long did it take exactly from the idea to organizing it? I think it was about 2 years that we said we have to do, is it correct? That we have to do this AI workshop, AI and Copernicus. The more we got into it, the more enthusiastic we were on the one side, but we also felt that it was very complex and moving at very fast pace. So we are very happy that we've organized it now, and as I said, it was really worth it. Why? Because we have such a long display now, or interesting display of examples of how AI is really a game changer for Earth observation and specifically for Copernicus. So we are also very grateful for all the demonstrations that we have had here. And a key takeaway is also that it really goes both ways now, speaking from the perspective of Copernicus. So AI as a tool to evolve and transform Copernicus, really in terms of the information that we can generate and how we can bring it to the users, how we can fuse it with other data. That's a true game changer for Copernicus, but also how Copernicus, as a source of big data in Europe, as one of the biggest generators of data in the world, how we can be a key pillar of driving AI development in Europe forward and driving it the European way forward. So this is something that we also have to think about, I think, how we can really put the fact that these data are generated by Europe, from Europe, bring them to the greatest benefit of Europe.
Thanks. How do you see the continuation of the uptake of AI ML methodologies in Copernicus? Do you see steady progress? Do you see step changes? How do you see the next few years?
I think we will see both in parallel. We will see some step changes and we also see steady progress. I think what is very important here is to realize that we have to embark on a transition from projects and demonstration to becoming fully operational. And especially you in ECMWF, you're already very advanced with the climate models that you have. So this is really the way to go. But also here during the last 2 days, we have heard a lot of examples, but it's still a bit of a patchwork. So I think now our job is to look at it more from the programmatic level. And key aspects that we have to keep in mind here is the word that I mentioned already, operational. So Copernicus is not a research project. Copernicus is an operational service delivery that needs to work around the clock. And what does it mean for the AI integration? So, for example, what are the implications on our data processing needs? What does it mean for HPCs? What does it mean in terms of connectivity and data transmission? So operationalization is a very important point. Another important point is sustainability. And what do I mean with it? Very simple, funding. And this is key as we are now discussing the future financial perspective. As you all know, the European Commission has put a proposal on the table. So making the AI revolution in Copernicus a true game changer, of course, requires the adequate funding. And the third key point that I have in mind from the programmatic level is making it European. And what we have to keep here in mind is dependency that we still have in the digital domain from the US, mainly on the infrastructure side. And for the software to really look at it in a very strategic and forward-looking perspective, to further evolve European models that we have, protect them at the same time as well, and also link it strategically with our research and innovation activities. We have this big and beautiful Horizon Europe, where I think we really need to make sure that we use it to build up our capacities here. So European way, and also how European way in terms of how we treat AI in more general terms. So for example, a point here is, I think, transparency as well for the user. As you all know, Copernicus is a user-focused, user-driven program. And here it's important as we integrate AI that we are also transparent to the user of where we use AI.
Thank you. Thank you very much. Yes, absolutely. Lots of key messages. I and myself, lots of things that are really important. Fighting fragmentation, I think that was a theme in the first panel that was mentioning, is probably something that is very important for us in Europe. We benefit from the diversity, but we need to fight the fragmentation. And with Copernicus and DestinE, we have big investment, at least at the scale of what colleagues out in other parts of the world are doing. So yeah, let's make it work. So let me move to the third panelist to have the view from a company. This workshop had participants from public, academia, companies. Aurélien comes from Kairos, who is a company active both in AI and in Earth observation. All these activities also should benefit the competitiveness of Europe. Competitiveness is the big word these days, rightly so. So what do you think of where we stand with Europe's plan in terms of AI and Earth observation?
Thank you. So thank you for having me.
And starting with the take-home from
yeah,
the workshop.
Sure. Thank you for having me in this panel. I'm honored to be here. So maybe first an observation. So I think so you are all aware of the past events of 2026. So there is, I think, a surge in uncertainties. So geopolitical uncertainties, and the next few years there will be also uncertainties due to the climate crisis, for example. Within this world, I do think that Earth observation can play a key role. So a technological role, of course, but also a strategic role. I think that's important to state that. Earth observation data, so they have to be useful for different use cases, but they have very good properties. So that can be a measure of the physical world. So comparatively, if we do the comparison to textual information, for example, that could be biased or manipulated or faked. That's like a really good property, for example. Earth observation can be also bring timely information, high quality and science-backed information. I think a lot of stakeholders in the world, so private or public or country, they ask for this information in those time of high uncertainties. For example, last week at Kairos, we provided a lot of data for the crisis in the Middle East around the supply chain of energy. So we monitor stock and also the supply chain of energy in these areas. So different stakeholders asked us questions, and we provided them with a measurement of physical world with physical world data.
This meeting is being recorded.
Yes.
So maybe another point is, so I think it's important to speak about the data we have in our hands. So obviously the Copernicus mission and services, so Sentinel-1, Sentinel-2, and all the Copernicus services that at Kairos we use, and I think a lot of companies in Europe use. So those are very important. I think also a very good property of this data is that they are part of a decadal or even multi-decadal plan and a multi-decadal roadmap. So that's very important for companies because we do need to also us to build model, to build algorithm, and to build services that work in the past and that will work in the next years, and have the transparency, the visibility it brings. So that's an important point for the companies. So yeah, and this data, so there is a lot of this data. There is a huge amount of remote sensing data, of Earth observation data. I think we are just beginning to scratch the possibility and the capabilities with this data. And the next mission is to really extract meaningful signal from this data. And I think the point of this workshop is artificial intelligence. So that's, I think, a good domain. Artificial intelligence is, in fact, able to extract meaningful information about this data, or at least in the future, we believe at Kairos at least that it will be the case. So the past few years, so really there was quite a shift, even a paradigm shift with artificial intelligence. I think a lot of people talked about that during this workshop, the coming of Earth Foundation model. So that quite an important shift, because I remember in 2018 when I began, we were working only with a fully supervised task only. Now with auto-supervised task, we really can play with different use cases, even if we don't have much label, which is like really costly for company. Another shift, I think, is really the use of transformer architecture in artificial intelligence. So in the past years also, that allow us to really play with different modalities of remote sensing data. So that's quite important to really serve different use cases and serve those use cases more precisely and with more accuracy. Yeah, so to conclude, I think the key takeaways is that Europe is well positioned. We have a lot of data, good quality data, and some technology has to be developed to extract the information from this data.
Thank you. Very reassuring. So let's take the temperature of one of the Copernicus services as a sample, important Copernicus service, because it's the emergency management. So Peter, so you've been here the 2 days. What are your key take-home from this workshop?
Yeah, thanks, Vincent-Henri. Well, first, if I can do the first take-home message with my hat on as a pure scientist and European, maybe. And indeed, what I've seen here in the last 2 days is an incredible amount of activities and an incredible amount of innovations. I mean, in particular, when we talk about AI, we always say, you know, there's lots going on in the US and in China. What are we doing? But I think the last 2 days have clearly been a proof that there's world-class developments in that field that come out of Europe. We've seen the impact of AI on predictions for weather, but also for the ocean, the usage of foundation models in all different kind of application area, the infrastructure that we're building, Euro HPC, AI factories, and here I say, as a scientist, obviously having access to something like Euro HPC is an absolute, you can't measure this because typically you don't have access to these types of systems, and I'm sure this is the same for companies and also for us. We use these facilities also as a service to do service evolution. So having all these things together really, I think, is a big plus and really enables us to move forward in that very fast moving world. And then, of course, all the work that we do as part of the Copernicus services, the evolution already also using AI. You've seen it also in the demonstrators. And then Destination Earth is our key programs, I think, in that sense. So the first key take-home message for me, at least, is there is a lot of activities and opportunities in Europe in the AI and Earth observation sector. And I think it's really great to see that, and we should continue enabling or enhancing those opportunities. The second key take-home message is, and that now with my hat on as somebody working on an operational Copernicus service, is a bit of a scary message, but I think we will all have to get ready, in particular when we look at operational service, to deal with orders of magnitude of more data. And the thing is, AI is, on the one hand, is the culprit for that, because if I run an AI model on a little laptop in a few seconds, then the products will be produced like this. We will have higher resolution. We will have more ensemble members. We will have more data, more analysis being available, and we need to find ways in an operational service to deal with this. But on the other hand, AI enables also to deal with that amount of data. We've seen the agents, for example, or the way that we can use this type of information to really make it digestible for users and decision makers. So that is for me the second key take-home message. It's a two-folded message in a sense that it's a challenge to be able to deal with all this large amount of data that I think will come in and very fast in the next few years. At the same time, it presents also an opportunity. So.
Thanks. And so these changes, I think you say that these changes for SEMS in particular are not just incremental. It's not just like a little increase in resolution. It's a paradigm shift. Could you give us some example of what is the shifts that are at play for SEMS?
Yeah. Yes. Yeah. I mean, indeed. I mean, in the AI really I think in many areas, but in particular also for disaster risk management and civil protection, emergency response is really, impacting the entire value chain. I mean, I talked already about impacts on AI and prediction and forecasting, usage of AI with Earth observation to, monitor burnt areas, flooded areas, or you name it. Is really bring an advancement also in quality and in speed and being able to process this data, but also when it comes to looking at impacts and the assessment of damages, which has been traditionally in disaster risk management, civil protection, a bit of a tricky aspect always. Also here, AI, we've seen a demonstrator here from our colleagues from the German civil protection, which I think is a good example to what can be done. And then to the last element, which is communication in disaster risk management and emergency response. That's a key aspect as well. So AI really enables us, for example, to use personalized warnings to really tailor it to a specific group, to a specific situation. So there are quite indeed, AI has really a big impact in particular on the emergency management service. Now, the challenges, and there are of course challenges associated to that, and one we've heard throughout this workshop all the time, and that is trust. Trust is is a key issue for everybody, but imagine in emergency response civil protection, this is really a key element. Imagine if you have to decide whether you want to evacuate a village, yes or no. So you really want to be sure that you trust the output of your model, and there's different ways to do so. So of course, transparency, explainability are key issues, but also running verification and testing in an operational environment. So there's different elements that can help to build that trust, but it needs to be done, and it will require some time, I think. And the other challenge that I see is a bit connected to also the second key take-home message, and this trust issue is the operational readiness. We see this field is moving so fast. We see every week, every month, there's a new model, there's a new system coming up, and I see great presentations and slides and whatever, but in our field, talking about operational readiness means 24/7, means high quality, means trust, and we will have to spend a lot of time to kind of look at what of the elements, also in particular with our users, which is something that is often forgotten. We need to be sure that whatever we do and implement in the services, and particularly also in the emergency management service, then is really responding to a user need.
So let's not be blinded by tech. What matters is really the value in terms of the information that helps taking decision. So first, heads up to all in the room and also online that after the last panelist, we'll open for questions. So start thinking about your questions. But before that, I will give the floor, last but not least, to Franz Himmler. Research and innovation, of course, is essential for everything in life, but for AI and Earth observation, maybe even more. So first, my usual question of what are your key take-home message, Franz, from this workshop?
Thank you, Vincent Herry, and thanks for giving me opportunity to sit here. I was really impressed the last 2 days, and I think I really like to thank the organizers for this amazing workshop, Mitch, and also the colleagues from HaDEA. Super interesting. What it showed and what is my key message is that in Europe, in this domain, we're really leading and we're really world-class, which is quite a surprising message. If you look at the news, Peter already mentioned it, normally it's said in Europe on AI, we're lagging far behind China and US anyway, so on. In this area, we're top of the notch. So, and that's quite interesting. And why is this? Would be an interesting question to look at. And I think there are several reasons. And one is certainly because we have these amazing programs in Europe, like Copernicus, which provides all the data, and we have the data. And for using AI, you need lots of data, and that's an area where we have it, while in other areas like social media, we don't have it, or we don't have the access to it. So that's one important. We have, apart from Copernicus, we have Destination Earth, another amazing program. And we have European institutions of world class which are able to produce or to make use of all this data and make use of these technologies that we have. And we have ECMWF, so the European institution. We have ESA with all the satellites and more data additional to Copernicus. We have EUMETSAT, Mercator Ocean, and so on. And we have amazing scientists that has also been shown here in Europe. We have smart people. No doubt, we have a private sector that is also super innovative and make use of this. So we have all the ingredients here in this place. And I think and that's my second key message, what is important that we really work together in Europe. And if we work together in Europe, we are world class and we can hardly be beaten by anybody. So that's, I think, an important take-home message to remember people. We nearly need this European collaboration. And of course, there Horizon Europe plays also a central role. We have started funding projects already many years back that made use of machine learning techniques and so on to really use this data. So there's a long history. It doesn't come from nothing. And this program, I think, was also essential to ensure that we are where we are now with all of this.
Thanks. So in your view, what are the key areas of research and innovation where we need to invest? So where Horizon and successor program will need to invest so that Europe not only keeps a good position worldwide, but maybe increases this advance, leverage all the data of Copernicus, leverage DestinE, the Gigafactory. So what are the specific areas maybe where you think this research investment is most needed?
Well, yes, I think it's all aspects, basically. It's still, I mean, we have reached quite something, but it's still a nascent technology, it's a nascent area. So there's huge potential all over the place. So I think we need to invest in everything, and it will be done. If you look at the proposal for the next MFF, there's a lot of money planned for investing in the digital part, in the space parts, and so on. So it needs everything. I think what is important and what I also learned here is we need the observations, of course, and also not only space-based, also in situ. We should not forget there's other Earth observation, not space-based. We need to keep investing in the physical models because that's what also quite clearly demonstrated here, because the AI models learn from the physical models. So if we don't have them, also the AI will be not intelligent, will be stupid. So that's also important not to forget. And finally, of course, in the AI models itself, foundational models, LLMs, etc., that's other people know that better than me. And maybe there's some other aspects. Peter mentioned already this trustworthiness, explainability, should not be forgotten and really being also part of the calls and of the projects to make sure that we can trust in the results that we get. And maybe another aspect that also came through in the last panel here, the risks. I think in this domain here, AI and Earth observation, the benefits very clearly outweigh the risks. While in other areas like the use of AI in social media, I'm not so sure, it's probably the other way around. But still, also in this area, we should look at what are potential risks to use this technology for society, for certain aspects of security, etc., etc. So I would mention this as well.
Thank you. Yes, yes, absolutely. And Peter gave an example of, so we are not a driving plane with AIs, but still there may be a life involved, or life or death involved in decision making supported by AI. So thank you all the panelists. So let me open the floor for wider questions or remarks from the audience. Let's start first from the room. If there are some interventions. I'm sorry, I don't see the full room. Don't see questions. Do we have questions online? Yeah. Yes.
So I guess this is a question for Babis, but what are the prospects for DestinE in the coming MFF?
Okay, well, that's a good one. So, first of all, as it was mentioned by my DDG, my Deputy Director General, in the beginning, the opening of the workshop, we will move from what we now know and call Destination Earth 1.0 to the new generation of Destination Earth, so Destination Earth 2.0. Actually putting all these elements that we are going now to develop until the end of phase 3 in motion and completing a digital, really fully digital replica of the Earth system. So there, of course, as we said, the synergies that we are now going to start discussing with Copernicus, with other partners, will become more prominent in the new MFF. So a part of how Destination Earth is going to be shaped, if you like, will depend also on these synergies, because it makes no sense that we continue alone. I think the clear message from this panel is that we can do it in Europe. We are aligning and we are joining forces. So we will work all together to continue on that. So again, I think that many exciting developments will come with the new MFF. We will continue like this. We always say in DigiConnect that we cannot predict the future in tech, so we cannot say what will happen in 5 or 6 years from now, but it's sure that AI will be there, I guess. And as I said, you will see a kind of more comprehensive now digital replica of the whole Earth system. All these thematic twins that you see now, they will join one major element, and then we will see also how we will work together, all of us, in order to go further.
Thanks.
Thanks. I can complement this from the Copernicus perspective. So we are working very closely with our colleagues and friends in DigiConnect in order to see how we can utilize well-developed, let's say, mature parts of Destination Earth and integrate them into the Copernicus services in order to give new functionalities to the services, but also to allow kind of for operational pathways for what has been developed in Destination Earth and to bring it to the user.
Thanks. No question from the room? Yeah, more? Okay.
So there's a question for Franz, and how would you imagine including instruments that would ensure trustworthiness of AI into future calls? Not a simple question.
That's a very simple question. We write in our call text, we write, please also consider trustworthiness and explainability and develop tools and methods on how to ensure that this is sufficiently considered. How people then do it, then you have to ask the scientists. I think we have seen it can be done, and there are ways of doing this properly, but there's certainly also risks. But I cannot say more than that.
Okay. Keep going.
So I guess this would be for everybody on the panel, but if you can imagine a conference in 2027, AI for EO. Which groups, topics, companies would you expect to see on the agenda? So for example, LiDAR, drone technology, any ideas? I mean, of what's coming?
Keros, maybe? You'll be there?
Yeah, so I think, we hope to be there. I think, next year, it's pretty interesting for radar. I think it's really a year for radar. So there is, of course, the biomass satellite from the Aerospace Agency, also an ISAR. And really, I think here, if we are talking about AI and foundation model, it may be one of the first times that we are able to for example, map the vertical height of the vegetation with by using transformer architecture and fusing different frequencies of radar, matching that to multispectral images also, and the phenology of multispectral images to map tree species, and then go to wood density and above ground biomass from volume and wood density. So I think this domain of multi-radar plus time series of multispectral images offer like really good opportunities, mostly for biodiversity, I guess, but I think other use cases. So that's one of the use cases that interests me next year.
Yeah, I think in my view, I mean, what we've seen is that in Europe we have quite now an ever-growing a company ecosystem that launched their own satellites and have their own constellations, and I think this is really encouraging. And I think one of the things, at least for emergency response, there is already activities ongoing. I think there's some projects from ESA is edge processing, so you will have the processing of the actual satellite image in orbit basically, and then you only get the results. Which is something we haven't seen here, I think, in the last 2 days. But this is something that I can imagine could be also coming up more with the fact that it's now actually easier for a private company to use and launch their own satellite constellation. Before that was basically, I think, an impossible idea. So that could be another, let's say, vision.
So besides what we all are now discussing, which is mainly on the software stack, I think there is a lot of potential, and this is what we are currently trying to do also, and I think we will do it in the competitiveness window to advance on the hardware side. So to really push the processing at space level. So new hardware, new equipment that could be used for that purpose. So I think this is a great opportunity, and we can even lead in this part in Europe. So that would be my take.
Yeah, for Copernicus, looking at the Copernicus services, you said 2027, right? So a reasonable time frame. I would like the land service to be much more powered by AI. We've seen a lot on climate, atmosphere, ocean. You talked about emergency, but I think we have a big potential on the land service. Second, linked to what you also just referred to, is space infrastructure, to see how AI can enable our space infrastructure. I'm not sure if I would like to see so much Copernicus images already kind of transformed by AI, because I think for researchers, the raw data is also very important, also to ensure the continuity and to use the data for all kinds of different purposes. But for example, to have AI-powered solution where smaller satellite companions could react immediately to information that they could get from the sentinels and so on. So there would be, I think, many possible things. And the third area is the users, or even broader citizens. So how can we unlock the AI potential to bring our Earth observation data to people that don't use it today? and also to interact with them, so that you basically tap on your phone in order to access Copernicus information that is relevant to you. And I think this would also have a big EU added value, because it would show to people, as they know that hopefully that Galileo was in their smartphones, that they would also know that it's the EU that brings this data to the people.
Yes, Franz.
Well, following what Tom alluded to earlier, that AI will take all our jobs, we probably don't have to bother about this question. It will be worked out by an AI tool, and probably up here would be a bunch of agentic AI bots discussing with each other. I don't know what. But seriously, I think one aspect that will become increasingly important in this more and more fragmented world is the European autonomy in this aspect. I think we're still very dependent on certain technologies that come from outside, and this technology independence, I think, should be one aspect that we need to work on and discuss how we can achieve it.
It's true what you said, Elisabeth, that making every European citizen feel they have a benefit from all the Earth observation that is available would be great. It's right that it's probably the top goal that we can have. It's very nice to have our information in news, etc., but people see that maybe from a distance. If this information is really driving the way they behave, the way they make their choices, not because they are constrained, but because they get all the information, that would be highly desirable. A last question, maybe, Nori, if and after Mitch has one. No.
Okay, sorry. So, in the spirit of we have only one planet, the question is, how can European institutions improve global collaboration, whether it's with the US, Japan, Latin America, you name it?
Question, Franz?
Well, actually, I think we're already quite good in this. There's a lot of international collaboration ongoing. I work for an international initiative called Group on Earth Observations, which has exactly this goal to really collaborate globally on the use of Earth observations for the benefit of society and for sustainable development all over the place. There are many other initiatives with Africa, with South America. INPA is funding a lot of activities in using Earth observation through the Global Gateway Initiative and so on. So I think there's a lot ongoing. Of course, could be done even more and maybe even more targeted in some place, but I think we're quite well, we do quite well on this aspect, so as far as I can tell.
Yes, if I may add my own view, it's a very, very collaborative international situation that is actually jeopardized. So I think the challenge is to keep what we have because it's working really well, and the new geopolitical context actually puts some risks on some of things that have been working for a very, very long time. So yeah.
Well, let me go one step back. Then on the international collaboration part, I think Copernicus has already an established presence in the international level. And we are also working via Destination Earth in a number of, let's say, outside Europe areas. For example, and this was a collective effort that we delivered all together, Copernicus, Destination Earth, and ECMWF, in the last, it was Hurricane Melissa, I think, in the Caribbean, where because there was a US absence there, we covered the ground, and we as Europe, not one or two, Europe as a whole, we provided the data and the simulations that they needed, the weather forecast for them to prepare the ground. So we do work also outside Europe. And I think there is, the question is very, very prominent because it's one planet in the end. But rest assured that we are not just limiting our efforts in the European continent.
So from the Copernicus perspective, I think we need to look at it from a strategic perspective. So we have a long-standing and important international collaboration that can go as far as launching together satellites, as we do it with the US, for example, for our Sentinel-6 or exchanging data as we do it with many partner countries, or coordinating our satellite constellations as we do it in the radar domain with Canada. So there is a lot of very, very beneficial international cooperation. And we also have a very strong international cooperation in order to bring our European data as a very important contribution to international initiatives, for example, in the ocean domain, where we contribute to the global ocean observation system with Copernicus. But at the same time, we also need to keep the strategic angle in mind of where the EU needs to have autonomy. So we talked about, you highlighted very nicely how we are top-notch on the models. This is something that we also need to be aware of, that we are leading, and to a certain degree we also need to protect that. And the second one is also on the technological side, like not only models but also technology at large, that we make sure that we have access to the technologies that we need, that yes, we are open and we have cooperation, but that we can also rely on ourselves if needed.
Yeah, maybe more a comment than a question, but I wanted to dig a bit further into competitiveness. It's not just a buzzword for us, but it's a clear priority of the Commission. And building on what Elizabeth was saying, you know, having people accessing Copernicus or DestinE on cell phones, right, would really foster the mass adoption of Copernicus and DestinE. And that would, by the way, also be the condition for sustainable businesses. Because once you reach this critical mass of users with some pay options, for example, or pay-per-use options, that's where really you reach this competitiveness business and sustainability in that framework. So maybe in the panel has some views on that, but I think this is maybe something we haven't invested enough in Copernicus so far. I mean, we see a lot of activities in the downstream sector, but we haven't seen really many examples of sustained businesses, you know, with sustained business models supported by enough users to make the case on the long term.
Other questions or comments? If not, maybe I will do a last round of questions with the panelists. Actually, it will not be long. The idea is to ask each panelist for 2 words, which are 2 of the key barriers that they think that Europe is facing today. So what are the 2 barriers that our collective effort should work towards reducing? I'm a chemist, so I always think in terms of reactions, and you know this barrier to overcome and then to get to your products is what is really important. So what are the barriers that we should try to fix as soon as possible? Babis. It's tough, yes, at the end of the day.
All right, so 2 key barriers. I mean, I think one is, as I said, I think it's common and we know it very well. I would say it's time to market. So we need to compete with the other players so that we are fast enough, as it was also discussed in the previous panel, so that we are competitive. And then the whole effort to lower the barrier when it comes to the raw material that we need in order to proceed from, because we are discussing a lot, but yes, chips are still manufactured elsewhere. We don't still possess the capacity to build them in Europe. Besides some really good efforts that we see now across our member states, still we need to grow. So if we want really to have the whole value chain delivering and also helping time to market, we need to make progress also on this part.
Okay, thanks. Time to market and raw materials. Elizabeth.
I would say it's the dependency that we still have on the data infrastructure. And the second one is the cost, as I mentioned already, funding.
Data infrastructure and cost. Aurélien?
So yes, I think infrastructure is key, and I do think we need a cloud provider in Europe so a champion cloud provider. So there is some, but so by experience, so at Keros we still use Amazon Web Services for a lot of our product and a lot of our application, because we are able to scale infinitely with those services, and that is not provided by any cloud provider in Europe at the moment. And even I know, so by working with different academic partners, that the use of Google Earth Engine is used a lot in the science layer too. And maybe a second point is I think the go-to-market is still a big headache for the company. So the product, the technology, I think we are very good, very well positioned in Europe, but create value from this technology and those data product is quite difficult and quite consume quite a lot of time and effort.
Okay, so cloud infrastructure and journey to market. Peter.
Yeah, well, that's a tricky one in particular, because basically the three before me have already mentioned quite a few points. I would have, and in a sense, this is similar what was said before. It's to bridge the gap between innovations and operations. In a sense, you could replace operations with market uptake, but I mean, again, speaking from an operational service, for me, working on trying to make this gap between, what is being developed so fast now, in particular in AI, bringing this into operations, that is for me, that's something that we should be working on.
So this proverbial last mile, which is very, very, very long.
Yeah, exactly.
And France, your two barriers.
I'm again the last, that's not fair.
Yeah.
I would maybe add to what was already said, fragmentation of data, access to socioeconomic data, interoperability of data. I think there's still a lot that needs to be done. And secondly, this technology dependence, what Aurélien was already mentioned too, this dependence on cloud infrastructure from non-European providers and other technologies could be also a barrier.
Okay, so interoperability and yes, technology infrastructure. Thank you very much. I see no hand or anyone wanting to comment, so it's time for us to thank the panelists. So big round of applause for the panelists. So thank you very much, and I hand over the mic to Mitch for the closing remarks.
Good. I feel relieved, I think. Unless I have to organize the 27. Yeah, good. I said I feel quite relieved. Well, unless I'm the volunteer or I've been volunteering for the 27 edition of this workshop. But I think those were some quite dense, fascinating, and exciting days. I hope you enjoyed the event. We heard about many different things around AI, this entire AI ecosystem. We heard about the AI revolution, high-performance computing, data infrastructures, users' needs, downstream exploitation, research and innovation, the future of AI and Earth observations in the last session, and not least also the demonstrations. And many thanks again for all these various inputs. On site, we're quite numerous. We clearly have beaten the record of Copernicus workshops big time. We're about 200 total. Online also, I hope the Q&A was a satisfactory way to contribute to this meeting. Unfortunately, there would have been a bit harder to organize a two-way interaction with people online. but at least, you know, I hope we were answering those questions reasonably well. We couldn't take all the questions, and we will follow up with those unanswered questions with also the different panelists and speakers. In terms of attendance as well online, we had the peak of 400 plus people at some times with a total of 2,500 connections, which is also quite impressive. We don't have the detailed statistics because of GDPR rules, but and by the way, congratulations to Italy. I don't know if Andrea is still in the room. Maybe is he still? Oh yeah, yeah. So as I told you, Italy has beaten the record for the, well, is the top #1 country with the largest connections to the webcast. Quite an achievement.
Andrea, it's all JRC, don't think.
Yeah, but for sure, for the next meeting, we'll need a bigger venue. And again, I'm not saying that I'm going to organize this. We'll see. So we saw ample evidence throughout the 2 days of the connections and the potential that's out there and opportunities that are out there between Earth observations and AI, also by inference, that also means between Copernicus and Destination Earth. So I think the future is bright, and there are a lot of prospects, and it's right time for us now to discuss all those cooperations across those two major thematics as we prepare also for the next MFF. So to paraphrase Churchill somewhat with my personal touch, and sorry for picking a UK person here, it's not the beginning of the beginning, nor the end. And I'm pretty sure you know this. Right? It's not even the beginning of the end, but it's perhaps the end of the beginning for AI and EU. So I like this sentence. All right. I cannot close this meeting without thanking quite a number of people. Of course, I haven't been alone organizing this. I'd like to thank the conveners. They were at the heart of the preparation of the program. Also the chairs, the speakers, the panelists, and the demonstrators. I think the chocolate bag is empty, so mission accomplished on that side. So congratulations again for playing the game and sticking to the schedule that made also our life easier, and so people had enough time also, for example, to go and watch the different demonstrations. I would like to thank you, the audience, because of your active participation also in the event. You know, and I hope also that on-site presence was also a nice opportunity for you, not only to listen to the talks, but of course benefiting also from the networking opportunities, and hope you've learned also as we went along through the program. As you know, these 2 days were co-organized between DG DEFIS and DG CONNECT, and I would like to thank Babi's team, in particular Bertrand and Daniel, who have been following up on a day-to-day basis the planning and have contributed to that. So please join me with a round of applause for our DG CONNECT people. I would like to thank also my fellow colleagues from ECMWF, in particular Vincent and Stein. So again, round of applause for them and all the rest. On the DG DEFIS side, we had also a lot of help from the colleagues from the Earth Observations Unit, in particular Hugo, Tim, Francesca, Stephen, Katarina, Tobias, Nori, Daniel, and of course, someone who is hiding behind a glass window over there is hiding now, Dirk and Raquel. Is Raquel in the room? Not yet, no? But a round of applause for them, please. I don't know whether the Blue Book trainees of DEFIS are in the room. Ask them. They are not there. That's a pity. If they come back, we'll thank them as well. Those are the people, you know, our next generation of AI and Earth observations experts. So at some point, you know, we will be retired, and you will see their face in these kind of meetings. We'd like to thank also the communication team at DG DEFIS, Theodora, Simos, Victor, Barbara from SCIC. You might not have noticed her, but she has been instrumental in sorting all kinds of issues. Barbara, can you wave maybe behind your window? Thank you very much. A kind of special feature of this meeting, as opposed to other workshops, was this demonstration element. And we'd like to thank Christina from the yoga club, or is it the origami club? I can't remember. Hey, Hugo. So they were very nice to us and lent us the room, so that facilitated also the flow and avoided too much crowd in the foyer itself. Thank also security. DEFIS means Defense Industry and Space, so we have to go through the gate and so forth, so it's not a building you enter in easily. So we'd like to thank them, and also OIB for all the, let's say, the furniture, tables and so forth. So that's almost, I'm almost at the end, but I cannot just stop here. And we have been co-organizing this event between DG DEFIS and DG CONNECT, but also with the large support from HaDEA. And I really would like to thank Marco's team, with Massimo, Ryan, and a very special person, Natasha. Could you come over here, please? By the way, this is always a risky exercise when you start thanking people, because you always miss someone. I'm pretty sure that there will be someone missing. But apologies for that. I hope that this thanking exercise encompasses everyone else. Yeah, let's do a round for everyone else.
Thank you so much.
You want to say a few words?
No, I want to say that this wouldn't have happened without you, actually, because you put all of us together. That has been a great initiative, and it's a great example of collaboration between services. So, you, DEFIS, CONNECT, HaDEA, GRC, all together, we work, a lot, but that's the outcome. So, no, thanks, many thanks to you. The flowers back to you.
Thank you, Natasha. I forgot one thing. Also, because of this strong cooperation between DG DEFIS and DG CONNECT, as a token of appreciation, I would like our CONNECT colleagues to go back to their Copernicus building. That's their destiny, by the way, to go back with one of the banners as a souvenir. Well, there is a smaller version than this one, right? So you pick the one you want. Yeah. All right. So with that, I think I've exhausted all my notes, I think. So with that, I wish you a nice evening. We may see some of you at the committee meetings tomorrow and Thursday, and otherwise for the others, safe travels home, and thank you again.